Good evening, everybody. Welcome to Modern Day Debate. I'm your host, Ryan. Tonight, we're going to be debating Flat Earth versus Globe Earth. And to start us off, we have Mike. Your old pal Mike is here to open us up. So, Mike, the floor is all yours.
I don't trust anything, bro, that I can't test for myself. I don't trust anything because I was lied to as a kid by Santa Claus.
All right. So coming to this tonight with almost no prep, but I guess in 2017 is when I first stumbled on this subject matter. That's when I first came across this stuff. And since that time, I've watched basically hundreds of hours of content, both on the heliocentric model as well as flat Earth content. I think just with my time, I just want to share one new experiment that I saw recently. It's just 3 minutes, so I'm gonna do screen share here a second.
Yep, go for it.
Pull this up.
Oh,
show one thing.
It was showing there for a second. We lost your screen share there, Mike. Oh, there it is.
Is it working now?
I think so. It's black right now, but that's just the YouTube video. Yeah, if you want to
All
go
right,
ahead.
here it goes.
Hello, everyone. I first wanted to thank Scott from Israel for sharing this information with me. I hope you find this evidence as exciting and compelling as I do. In short, this is another world record proof of the flat Earth. This evidence alone ends the globe. The world record comes from this website called The Things Network. I'll have a link in the description. As the title states, this was a LoRa radio transmission at a whopping distance of 830 miles or 1,336 kilometers. For those who do not know, LoRa is actually becoming a very important method of communication, and it also has tremendous potential for long-distance flat Earth testing. Here's a quick video clip describing what LoRa is.
LoRa stands for long range, and it's a relatively new communication standard targeting low power, long range, low bitrate communication. So it's really finding applications in Internet of Things, remote sensors, anything that requires low power consumption and a moderate to low bandwidth.
LoRa is in the ultra-high frequency, UHF, radio bandwidth, between 860 to 930 megahertz. It is important to note that UHF does not, even allegedly, bend with the curvature of the Earth. In fact, according to this website, LoRa is line of sight. According to the article, LoRa's range depends on radio line of sight. Radio waves in the 400 to 900 megahertz range may pass through some obstructions, depending on their composition, but will be absorbed or reflected otherwise. This means that the signal can potentially reach as far as the horizon, as long as there are no physical barriers to block it. In other words, LoRa communications end at the alleged globe geometric horizon. But this world record LoRa communication was at a distance of 830 miles. What makes this even more remarkable is that the LoRaWAN trackers were placed on a fishing boat and a buoy. Here are the pictures. This world record communication occurred at almost sea level. Assuming an observer height of 20 feet, that gives us a globe target hidden height of 448,550 feet, or 85 miles. At only 20 feet, the signal from the boat should have been blocked by the supposed Earth's bulge at around 5.5 miles. There is only one reasonable conclusion. The Earth has no curvature. The Earth is flat. Thanks for watching.
So that's just one of just 50, 60, 70 experiments I've seen since 2017, using a whole variety of modern ways to demonstrate that the curvature that should exist on the globe model Earth can never be detected. So, yeah, that's it, I guess. So.
There we go. Get that preamp turned up. Thank you so much for your intro there, Mike. We're going to hand it over to Flatter-Day Saint. Thank you for being here. We want to remind everybody before we do that Modern Day Debate is a neutral debate platform hosting debates on science, politics, religion. We hope you feel welcome. Flatter-Day Saint, the floor is all yours.
What up? I didn't have much time to prepare, but I don't really need to take notes or anything. It's all in my head what I need to say. So, I guess I became a flat earther in 2017. Technically, everybody on Earth is a flat earther. A lot of people just don't realize it yet. But like all animals, trees, plants, people, they're all flat earthers because we live on a flat stationary plane. Just a few things to start off with. The most simple, basic one is water. Water always finds its true level, no matter what shape or how big the container is. So supposedly, according to modern science, Earth is like something like 71% water. So regardless of what shape the actual land is, the water is flat all the way across. So, I'm not saying that Earth is completely flat. There's hills and valleys, ups and downs, but it's a topographical plane, and water will prove that. Unless anybody can show an experiment of water bending around a ball, let alone a spinning ball. But water, from what I've seen on my time on Earth, is that it doesn't bend or warp. It always finds its true level when unmanipulated. So that's one of the things right there. You go into the fact that the North Star never moves, and all the stars make a perfect circle around it every night. And like Mike said I was going to talk about the electromagnetic field, the propagation of electromagnetic fields over flat Earth. There's a lot of military documents that state that it's a flat Earth, because of course the signals wouldn't work if it wasn't a flat Earth. So it's just it's pretty simple. The whole thing is, a lot of people say like, well, how could that many people be in on it? But I mean, I don't think that's not a good enough reason to not look into something, And other people say, well, what difference does it make whether it's round or flat at the end of the day? We're all going to die. But this is what I think. I think that because we were lied to, and the lie is so extensive, the most important thing that they could be hiding or taking away from us is maybe people were meant to live 2 or 3 times longer than they are, if they understood the way everything works on a stationary plane and the way the stars and the luminaries rotate around us. But we've been so, from the time we were kids, the lie about Santa Claus, and then they tell us Santa Claus is from the North Pole, and then when we finally learn about the globe, the North Pole is hidden with a metal cap and a pole like a metal rod through it. So when we start thinking about the North Pole, we just dismiss it with Santa Claus. So I mean, the lie goes way back from, we're told that Santa Claus is real, but then we're told that lies are bad. So it's like, it's double speak Negalian dialect from the gate. We don't have much of a chance from the gate. So hopefully this reaches just one person, even for them to get up and actually look for themselves. All right. Thank you.
All right. Well, thank you for your opening statement there, Flatter-Day Saint. We're going to kick it over to the globe side. Now, my understanding is that we were having a little bit of issue with a screen share there. So Dr. Tapiocaweasel is going to share their screen and go through, base theories PowerPoint here. I got to get everybody's names put together there. So without further ado, Base Theory, the floor is all yours.
Yeah, sorry about the technical issues, everyone. My debate partner is going to be having to share my PowerPoint. My name is Grayson. My YouTube channel is Based Theory. I do debates on all kinds of pseudoscience, flat earth, young earth creationism, the whole works. I do open mic debates too. Come by, check it out if you want to debate with me. Anyways, for tonight, since we didn't really have that much to go off of, I didn't know what my opponents would be presenting. I just thought I would present some reasons why flat earth is impossible. So as you can see on the screen, there is tons and tons of reasons to choose from. Each one of these completely debunks the flat earth, and I could have chosen any of them. But for the sake of time, I decided to go with just 2. So Tapioca, could you go ahead and click once? The first one I want to talk about is sunsets, because the mere existence of sunsets is impossible on a flat earth. I don't know any way that you could possibly describe how a sunset happens on the flat earth, and we're going to get into that. I chose this because it's something that everyone can see with their own eyes. You don't need some special equipment. You can look at a sunset. Everyone's seen them. Click again. The second one is a little bit more technical and scientific, but it's one of my personal favorites. I just think it's really neat. It's called antipodal focusing. Hopefully we can get in and we can talk about what that is, because I think it's criminally underrated in this discussion. Next. So here's just a picture of a sunset. Everybody knows what they're looking at. It's really pretty. You can see it go down step by step there, getting further, more and more obstructed by the horizon, the ground, whatever you want to call it. This is what needs to be explained. Go ahead and click. Here is a flat Earth model that I've seen. I know that lots of flat earthers say that we don't really have a definitive model, but this is just an idea of what I've typically seen, where the sun is small and local, sitting above some part of the plane of the topographical plane Earth or whatever. And you can see about half of it is in daylight and half of it is at night at any given time, which should not be possible given this image. If you could go ahead and click once, you can see here that from the sun, the sunlight is hitting the part that is daylight. That makes sense to me. There's nothing to obstruct it from hitting that spot on the Earth. Click again. Here we have what should be happening. There's absolutely nothing to obstruct this sunlight from hitting the part of the Earth that's supposed to be in night. The way that this is depicted, it's not possible that there would be a night. There is nothing to obstruct the sun's rays from hitting the part of the Earth that is at night. There should be no such thing as nighttime if the Earth is flat. Go ahead and click it one time. Here's my question. So I'm sitting here in Dallas. Shout outs to Modern Day Debate Con 4 going on in Dallas in November. Get your tickets early. But how is it that the sun can be setting here in Dallas while at the same time the sun is right at the zenith of the sky in Fiji at noon? How can that happen in the flat Earth? Go ahead and click it one more time. So if the sun was really small and local above our heads, and it was the distance to it that was causing this, shift in perspective. I often hear that flat earthers say this is the sunset is due to perspective. Well, we have math to describe the laws of perspective. We can calculate what the angular diameter of the sun should be based on the distance at the bottom of the triangle between Dallas and Fiji. We can calculate what the difference of diameter would be if it was directly overhead in Fiji, and we can see what I should see in Dallas. But in reality, as it's shown here, there's a lot of math on this screen, but the main important thing is that there's an equation for angular diameter, and the angular diameter of the sun does not vary very much at all. It stays pretty much constant all day, all night, like the whole year. We measure the angular diameter of the sun. It doesn't vary very much. So this shows that the sun cannot be small and local above our heads like in a flat Earth. One more time, click Tapioca. Okay, so here's a few questions I have about sunset. Why is the sun obstructed from the bottom up? What causes it to have that directionality? What is obstructing the sun at all? What is it what is blocking the sunlight? Because in the flat Earth models, nothing is blocking the sunlight when we can't see it at night. So it makes perfect sense in a heliocentric spherical Earth model because the actual Earth is blocking the sunset. But on a flat Earth, the sun never goes below the plane of the Earth. So if the sun is never going below the plane of the Earth, how could we see it being obstructed by the horizon? It doesn't make sense. So then why doesn't the angular size of the sun change? Why is the horizon crisp and clear and not blurred? If this was truly because the sun was going farther and it was because of perspective, we would see it get blurrier and blurrier and as it goes farther away until eventually we wouldn't be able to see it at all because it's too far away, but it would be very, very blurry. And yet the sun is crisp, the horizon is crisp, they're not blurred, no blurring, no flat Earth. And finally, why is it that after the sun's not yet, Debbie, why is it that after the sun sets, you can take a drone with a camera and just increase the altitude, and then you can get the sun to be visible again after it has set for you on ground level? Why would that be possible on a flat Earth? No flat Earth model, to my knowledge, is able to answer these questions in the same way that a spheroidal Earth heliocentric model can. Okay, next, real quick, antipodal focusing. What am I talking about here? An antipode is just the complete opposite side of the Earth as a globe. So in this picture here on the left-hand side, you can see that there's an impact crater from a meteor in red at the very top there, just north of South America. So the antipode of that is down in Australia. That's what the right-hand side is showing, that if you were to dig a tunnel all the way through the core of the Earth, you would come out at Australia if you started digging where that red impact zone is. So with antipodal focusing, when you have a meteorite, or you have an earthquake or volcano, some kind of big seismic event, or anything that is outputting waves, they're going to spread in 360 degrees, spread in all directions from that initial epicenter point until they get all the way around the diameter of the Earth. And then they start converging, and they converge all the way on the antipode. Remember, the exact opposite side. So what we see is actually the strength of those signals gets stronger and stronger the closer that you get to the antipode. That's what we can see here on the right-hand side, where the seismographic readings are getting stronger and stronger at the antipode in Australia from that initial impact. Go next. So has this ever been observed, right? Here is an actual observation. In 2010, there was a magnitude 5.3 earthquake in the Indian Ocean. Now, the antipode for this earthquake is right here in the center of the United States, where it was detected by every single dot on the screen there. That's a seismograph. So it was detected by all of these seismographs. We're detecting the seismic waves converge onto that antipode point. This was detected. Press next. Here is the study that detected it, antipodal focusing of seismic waves observed with the US array. So here is their study of their actual observations showing that the seismic waves were focused at that antipode, which should only happen if the Earth is spheroidal. There's no reason why the antipode would be special in any way on a flat Earth. It should just, it's the opposite side on a spherical Earth. So it has significance if the Earth is spheroidal, and we can actually measure that there is something significant happening there. The seismic waves are focusing and gaining strength at the closer they get to that antipode. Next, if you don't believe me with this one, how about all of these? Here's a list of every major earthquake and volcano on the left-hand column from 1934 to 2017, anything that was over an 8.6 on the Richter scale. And
is this 6 minutes?
He's past 6 minutes, but we did say earlier that he had a bit more. Yeah, he's got a bit more presentation.
I'm almost done. And we'll have 12 minutes total. Don't worry. On the right-hand side, you can see the corresponding seismic activity as measured at the antipode. So there is a strong relational signal between the epicenter and the antipode. We can measure the seismic activity there. And then this is my last slide. I just want to say on the next screen that this also occurs for radio waves. So not just seismic waves, we can do the same thing with radio waves. So radio signals, like kind of what you were talking about, radio waves, as they spread out from the epicenter, you can start to find a stronger and stronger signal the closer you get to the antipode. There is no way that that's physically going to be possible on a flat Earth model. And I'll just leave it there. Here's a list of 10 studies that are all showing antipodal focusing using radio waves. That's all.
So yeah, that leaves you with around like 4 minutes there, Dr. Tapiocaweasel there. So thank you so much for your intro there, base theory. I do want to let everybody know, because of our conversation prior to the debate with the screen share, that we did agree to let Grayson have a little bit extra time to go over his presentation. So without further ado, over to you, Doctor, your thoughts and your intro. Thank you for being here.
Hello. Yeah, it's good to be here. It's my first time actually doing a debate or being on MDD here. I am a real quote unquote doctor. I have a PhD in physics, but it's not a PhD in like geophysics or geography or something like that. I think Grayson really made some excellent points, and I don't have a whole lot to add. I would generally say that what I've noticed in my interactions with flat earthers is a lot of equivocation on what various terms mean. And for example, what does it mean for water to find its own level? What I would say is that it conforms on average to an equipotential or an equi-effective potential surface in your given model, and you'd have to calculate that accordingly. But generally speaking, I think that the problem fundamentally is that there is no model. There is no flat Earth model. There is no ability for flat earthers to start from an a priori idea of what the universe looks like, of where objects in the sky are, and then to explain how the light gets from those objects to observers on Earth that is consistent for all observers on Earth and for all objects in the sky. This is not a problem that the globe model has. The globe model is able to predict with astonishing accuracy exactly where we are going to see things in the sky. And if you don't see things in the sky where the globe model predicts, it's because it's cloudy, not because it's not there. So I have often said, somewhat mockingly and certainly informally, that as far as I can tell, all you need to do to prove that the Earth is round is have a knowledge of the night sky, a knowledge of how light moves roughly, and the ability to think in 3 dimensions.
All right. Well, not quite 12 minutes. That's A1. We're going to kick it into our open discussion, everybody. We're glad that you're here at Modern Day Debate. Just want to let you all know that we do have our link to DebateCon 4 in the description right now. So if you're going to be in the area and you can get tickets, that'd be awesome. We'd love to see you there. If you can't make it and you're not going to be in the area, you can still contribute at the Indiegogo link. We appreciate anybody who puts anything in there to help out and sponsor this event. But majoritively, I want to let you all know, as per usual, we will be doing a Q&A at the end of this conversation, so get your super chats in now so they'll be read nice and early. We're going to kick it over to the flat side to respond to what they just heard and kick us into our open discussion. So thanks everybody for being here, and over to you, Mike and Flatter Day Saints.
I have some observable documented evidence that contradicts what Grayson said about the sun. If I could share that real quick, pull this up.
Sure thing. I think that's going to be a big part of our discussion tonight here. I think everybody brought up the sun, day and night, so we're going to...
One here, it's about 3 miles to the horizon when you're standing at sea level. This camera is capable of zooming far beyond that. As we can see, the sun is setting behind the horizon. On the globe model Earth, that means that the Earth is turning away from the sun. Well, if we just watch this and someone zooms in on it, see the sun get closer, closer. It's going miles and miles out till it's clearly above the waterline. So you have to now decide whether the curvature of the Earth is not there, or if this camera has the magical ability to turn back that curvature, because the horizon line is only a few miles out. And as you can see, with the powerful enough zoom lens, you can bring the sun back above the curvature. And the other observation I'd like to share that contradicts his sun statement, or goes in line with his sun statement, is he said that, the sun should basically shrink in size if it's moving away on a flat Earth, because it should. If the Earth is flat, it should shrink in size as it moves away. Well, here's footage where out in a desert where there's low humidity, you can watch him do time lapse of the sun moving away. And as you watch it, you will see it shrink in size, and he will mark the sun. So as you see, observable reality absolutely confirms what our model says should occur. So to say that those things aren't occurring is one thing, but as we just saw, they are visually occurring within observable reality. And that's been my biggest problem with the heliocentric model, is that I found contradiction after contradiction within observable reality that contradicts the heliocentric model. I understand that the model works on paper, but reality contradicts it in many, many ways, which I'm more than willing to share this evening. But I did want to show that those statements are untrue about the sun.
Okay. I'd like to make a comment and just ask a question real quick. Now, number one, I just want to say, why is it that flat earthers never use solar filters in any of their videos or pictures of the sun? Something that is absolutely necessary to get rid of glare or any optical effects on your camera.
Saturation.
Yeah, is a solar filter. this would be unquestioning if a flat earther could show with a solar filter on their camera any of the things that Mike just laid out. But again, there's no solar filter. Curious why that wouldn't be the case. When you actually measure the angular diameter using a solar filter, or if you want special sunglasses or whatever, you can look at this yourself. Go out. I encourage everyone, don't look at the sun without sunglasses, without the special glasses. But with the glasses, you can look at the sun. You can watch the sunset yourself and tell me if you see it shrink. Because what he just saw in the video, I think everyone that's ever seen a sunset can say, yeah, that doesn't happen in real life.
Well,
I mean, have you ever seen the sun shrink in a sunset? Have you seen it yourself?
Yeah, I live by the beach. I grew up in Dana Point, so I watch it set over the ocean all the time, my whole life.
Yeah.
And anyone can also simultaneously go down to the beach with a high-powered telescopic zoom lens and watch that sunset beyond when the Earth should have turned past it and zoom and bring it back into focus. And
For how
that's
long?
a lie. I've grown up by the beach my whole life. How do you explain that? Why didn't it? Is the camera able to bring back the curve when I'm standing on the beach and it should be gone 3 miles out and my camera can zoom 10, 15 miles out?
How long, how many minutes after the sun has set, after the last little bit that you see with your eyes has gone below the horizon, how many minutes after that can you stand there with a telescopic lens and bring the sun back into view?
I'll do you one better. I got time-lapse footage.
I don't want you to do me one better. I want you to answer the question. What
do you mean? How long does it take for the sun to set over the horizon, and how long can I film it for?
Which part tripped you up? The question I was asking was the sun sets. So yes. you see a disk. Okay, the sun looks like a disk. If you have sufficient filters so that your sensing equipment, a camera, or God forbid your eyes, which hopefully you're using some good, safe filters for, it's going to look like a disk with a very clearly defined outer edge, and the inner portions are not going to be saturated. If the inner portions are saturated, you no longer have fidelity in your measuring apparatus. So therefore, if you're not saturating the thing and you're going to see a clearly outlined disk, and if you disagree with this, then let me know. But eventually that disk is going to go down and you're going to see the bottom part of the disk cut off, and then the middle part is going to be like a half thing, and then the very edge. My question is this. You are asserting that when you go back and you zoom in with a telescopic lens, that you can bring back the sun after that little bit has gone under. And I'm asking you how long? Because surely you don't think that 6 hours later you can do it.
No, I actually don't even have an answer for that question, but I have video footage of a boat sailing out to sea for 25 minutes using time-lapse footage, and you can measure the rate of speed that the boat is traveling and how far it's gone and its distance, and it's way beyond the geometric horizon of the globe model Earth, but it can be brought back into view with the with a telescopic zoom lens. Long beyond when it should have set. You can measure it. It's all measurable. Like you said, how much time, it's measured moment by moment. It's got a time stamp on it, every single second of it. It can be paused. It's broken down. It shows the height of the boat. Moment by moment, every minute, time-lapse footage, beyond when it should have gone, long beyond when the whole boat should have disappeared.
So, Mike,
how is that explained?
So, Mike, you've said that you've done this yourself, right? You said that you've gone out there with a telescopic lens on the beach and you've shown the sun. Surely it wasn't just the video that you just showed us now, because that wasn't you. But if you have this, get a solar filter, illustrate what you're saying, and see how long you can actually do that for to be able to answer Tapiocaweasel's question. And I think if you did that, maybe you wouldn't be a flat earther anymore.
I don't see how that changes the fact that experiments show that the necessary curvature doesn't exist. By using a solar, that's assuming a height. What height are you assuming the sun is at?
Okay,
what diameter are you assuming the sun is at?
You can measure the angular diameter yourself using a solar filter and equipment, but here's the thing, is that you were claiming that it's beyond the geometric horizon, right? But we don't see the geometric horizon. We see the visible horizon, right? So you didn't, in your little experiment where you're showing the boat come back in, you didn't measure the lapse rate. You didn't measure any of the surrounding effects that would be able to affect the visible horizon. You need to account for your variables if you're going to be.
Absolutely.
Okay.
I have the greatest series of laser experiments ever conducted over a 2-year period of time, where they account for humidity so they can take into account the expected level of refraction.
Okay.
I've watched it all. They do a wonderful job. And you're asking what I've personally done. I can share with you something that debunks the heliocentric model that I've personally documented 7 or 8 times, that I have footage of, that I can share, and I can prove to you that it's out of place according to your model, if you want to see it.
Sure.
Okay.
Well, before you go ahead and do that,
let's let someone else. I don't want to dominate the time.
I know. I was going to say, while you're bringing that up, I did have some points on what Flat Earth Saints was talking about with one, that the North Star does move around a little bit. Okay.
Yes.
It's like a little bit of a circle. Everybody knows that.
Yes.
Water finding its level, like level is like just defined by being perpendicular to like the effects of gravity. So obviously the direction of gravity changes around the globe. So like level is going to change as like the downward acceleration of gravity changes direction. So obviously
you're invoking gravity.
The last point I was going to say, which is with ground wave propagation, since both of you kind of brought that up with radio waves, I just want to say, like, we know how ground wave propagation works, and you can do this yourself over a hill. Like, according to you, you think that it can't hug the surface of the Earth, but
Depends
just
on the
go ahead and send them over a hill, and you'll see that you can get those radio signals down in the valley on the other side of the hill, because it hugs the surface of the valley all the way up and all the way down, because of diffraction.
I'm just going to jump in here. Let's let
depends on the frequency. Not all RF waves are the same. They have different levels. Lower frequencies can do what you're describing.
Yeah.
Higher frequencies are line of sight. The example I used, there was 85 miles missing. 85 miles of drop that should have been there, line of sight, that wasn't there. It's just undeniable.
And in the 10 references that I showed was with radio waves, including those of medium frequencies, going all the way around the whole world to the antipode and getting stronger at the antipode.
We need to let Flat Earth Saint respond, because you are addressing his points there. So first, about the water level there, over to you, Flat Earth Saints.
So you invoked gravity when you mentioned the water levels.
Yep.
How do you measure your gravity?
There's a number of different experiments that you can do. Cavendish was
the
first to measure it really well.
He measured gravity?
Yeah, he hung balls in his shed and looked through a hole.
So I can debunk gravity, bro, with a magnet. I could stick a magnet to the fridge and it could sit there indefinitely. And I can debunk gravity.
How do you, in your mind, how do you think that debunks gravity? Because there's another force that's stronger than gravity that somehow means gravity's not real?
Yeah, it's way stronger than this supposed gravity, but gravity can't be measured. There's no way you can measure gravity. What would you use to measure it?
Are you familiar with the Cavendish experiment that measured the gravitational acceleration?
So what type of gravity are you talking about?
We're talking about the fact that between two different test masses, you are going to have a force that is attractive between the two. On Earth, this manifests as things tend to accelerate downward because that's where all the mass is. There's a big ball of mass called Earth, and that causes a gravitational field, and it pulls things down. And we can measure that very precisely. You can measure it at the bottom. You can measure that at one level, and then you can perform the same measurement 10 meters higher, and you get a different value because you're further away from Earth.
So you're saying you can measure that on a small scale or on a large scale, right?
You can measure that on a large scale. For example, you brought up
on any scale.
What about a small scale?
Not any scale, but yeah.
You brought up the military.
How small do you want? How small do you want?
Well, I just want you to show me an experiment where water can stick to a ball.
Okay, that's not what you asked. What you asked is to show you gravity on a small scale, and I'm going to interpret that as gravity changing in its magnitude over a small scale. Now, hold on. Are you going to let me finish?
We'll wrap it up.
So, So there are experiments where the clock rate of a layer of atoms in a ultra cold gas of atoms that is trapped inside an optical lattice where the top layer of atoms and the bottom layer of atoms are 100 microns across, like difference. The top layer is only 100 microns higher than the bottom. A micron is a millionth of a meter. It's 100 microns is about, hold on, I'm not done. It's about the width of a human hair. And the redshift, the gravitational redshift between those two layers of atoms, which is a phenomenon that shouldn't even exist on a flat Earth, matches the predictions. You can tell that clocks tick slower if you raise them up by the amount of a human hair. We can and did measure that. My advisor in grad school did it.
Let me get the
just
citation.
So y'all know.
All right, let's let Flatter Dave respond.
I just want to clarify, just so y'all know, this is what Tapiocaweasel does for a living. So he's got firsthand experience here.
All right, let's let Flatter
I'm glad
Dave
you're white
respond.
knighting for him, bro. Let me get the citation for that. The name of the experiment, the citation.
I'll look it up for you.
And while he's doing that, I just wanted to say, as long as we brought up the military, they've literally made maps that submarines can follow based on the strength of gravity. So when you're out in a submarine in the middle of the ocean, you can just map the strength of the force of gravity. And because it's different based on, like, if you have a straight line to the center of the Earth, depending on the amount of matter that's in between, so like the strength of gravity will be different if there's an undersea ocean there, because there's going to be more mass directly beneath you. So you can actually make a map based only on measurements of gravity that is accurate for the navigation of Navy submarines.
So like the United Nations map that they have for their logo?
No, hold on real quick. What tool do they use in the submarine that measures the gravity?
An accelerometer.
Accelerometers do not measure gravity, dude.
They measure acceleration.
Yes, they do.
And gravity is the downward acceleration.
Gravity.
Gravity is the downward acceleration.
So how far does the submarine
But you're
go
saying
down
the
before they
way
stop
the
going
submarine
down?
is measuring gravity is with an accelerometer, but accelerometers do not measure gravity. Anyone can look that up. That's not a true statement. So I'm asking you, you're saying submarines, you make maps measuring gravity. I'm curious the tool they make the map with that measures the gravity.
There are two main ways.
Yeah.
Okay.
There are two main ways that the acceleration due to gravity is measured. A very easy, straightforward way is to drop a corner cube in a vacuum. You drop a corner cube, you make sure, and you have to do systematic analysis. For example, it's possible, that the corner cube that you're dropping has a slight electric charge, and therefore there will be a force on it. So, for example, you do the entire thing inside a metal container, and according to Gauss's law, which if you can show me an example where that isn't valid, then you'll win the Nobel Prize, there's going to be no electric field inside that container. Therefore, the only thing that's going on this thing is gravity and the very, very, very small and extremely precisely quantifiable upward force of the laser that you are bouncing off of the corner cube in order to measure the speed. So what happens is you have a corner cube and you send a laser up and it comes back down and it interferes with itself and it counts fringes. As it moves down, the interference thing changes and you can count exactly how many wavelengths this thing has moved. This gives you an exceptionally precise measurement of the exact position versus time as the corner cube falls. That's one way. The other way,
that had nothing
and the way that I prefer is to use.
Okay, but
let's respond to that first point.
I let you just give a whole explanation that had nothing to do with my question. My question is, what is the name and model number? Like, for instance, I have an experiment where a guy drove around Lake Erie, a 200-mile drive. He used the MPU 6050 digital accelerometer and gyroscope to measure for pitch. In 200 miles, his digital accelerometer and gyroscope did not pick up the curvature of the Earth. That's the device he used. You're saying submarines measure gravity, and you're explaining how calculations work in a different experiment that does not have to do. I'm asking what the device is.
So there are commercially available gravimeters that can measure the strength of gravity depending on your location. So you can go and buy a gravimeter yourself, and they have gravimeters that are state of the
I
art.
was just wondering what the submarine uses.
I don't buy
the
off
submarine
the
uses a gravimeter. The submarine makes a map using a gravimeter.
Bro, I don't do these things with off the shelf parts. Okay, I'm a physicist. I actually do the physics. Okay.
Yeah, the math. I get it.
Well, okay. If you
I know the math works
fake,
in that model. I know it works. I'm not arguing with your math. What I'm arguing is that observable reality contradicts
what
the
I'm
math.
saying is okay, can you explain why an object at the bottom of the chamber will fall faster than an object at the top of the chamber when you have controlled for every other thing that we can possibly measure?
I'm not sure the experiment you're referencing.
I'm saying that if you drop an object from a high thing and you measure how fast it accelerates in its first 10 centimeters, and then you drop it from a meter lower, and it will accelerate at a different rate. It'll accelerate faster because it's closer to the force of gravity. This is not a controversial.
It's closer to the electromagnetic field of the Earth.
I already said
negative charge.
Did you forget the part?
Has a
did you forget the part where I embedded this entire thing inside a metal chamber? And according to Gauss's law, which, again, if you can show an example where that is not true, then you win a Nobel Prize. There is no electric field. There is no electric field inside a conducting chamber. So
space-time is making that happen. Space-time is bending around it because all these objects are spinning, and that's the only explanation. There's no other explanation.
You're changing the subject. He just asked you to explain it in your model. We haven't brought up space-time. Gravity
is space-time. That's the definition.
We're asking you to explain what he just said.
Definition. But
I can admit that I don't have an explanation. What you're saying is the only way this can happen is if the Earth is a big spheroid hurling through an expanding vacuum. And what I'm saying is I have a bunch of examples that prove that nonsense.
You don't.
The more that technology advances, the more people are coming to terms with that.
Okay, so let's see one then. You say you have all this evidence for it.
You want to see one that I did personally?
By the way, I provided the reference you asked for earlier. I provided the reference about the differential gravitational force and the gravitational effect between the top and the bottom of an ultra cold atomic sample. I put it in the Zoom chat. I have another different reference here, absolute airborne graviometry with a cold atom sensor, which uses the other method that I was going to talk about in order to measure the gravitational acceleration, which is to use an atom interferometer. And this is my preferred one because it uses quantum mechanics, and quantum mechanics is super cool. They flew a plane over Iceland, and when the plane was over the mountain, gravity was stronger, by which I mean the thing accelerated downward more quickly than when they weren't over the mountain. And when they were flying east, the thing accelerated downward less quickly than when they were flying west. This is the Edavos effect, and it is a direct demonstration of the rotation of the Earth. So you have gravity demonstrated, and you have the rotation of the Earth demonstrated very beautifully in this experiment. The title of the paper, again, is Absolute Graviometry, Absolute Airborne Gravimetry with a Cold Atom Sensor by Bedell et al.
Let's get flatter data here.
So you're saying at certain places the plane got pulled down stronger than it did in other places?
Yes.
Yeah.
Okay, so did the pilot have to adjust for that?
It was a part in what was the part?
It's very, very small effect. Like
so it's so small, only the sensor would pick it up, but it's not noticeable to people, so it's theoretical.
That's not
theoretical.
You're equivocating. Just because it's not noticeable to people does not make something theoretical. They measured it. It's not theoretical. It is empirically observed. Just the fact is that the turbulence just from the plane moving in the air is going to be a greater, more noticeable thing to the pilot than this effect.
Also, what the pilot has the ability to detect is determined by their inner ear. Their inner ear is a lot less sensitive than a state-of-the-art physics experiment designed to measure this stuff. This should not be a surprise.
So you're saying that it's something that we can't see, taste, touch, feel, or hear, but I'm going to take your word for it because the numbers match up and the machine said so.
Flat Earth Day Saints, can I ask you a quick
Sounds
question? Do you think atoms are real and physical? Because you can't see, hear, touch, taste an atom.
Show me a picture of one, not a cartoon.
So you don't believe in atoms?
I'll honestly admit that I'm not saying I don't believe in atoms, but I do feel like everyone's re-examining all areas of science right now, including like stuff that's called quantum physics. That's science. We should always be re-reviewing. We shouldn't laugh at that. That's how we learn.
Yeah, but nobody.
I believe in Adam and Eve.
All right.
I believe in Adam and Eve.
Let's let Mike wrap up his thought there, and then we'll kick it back over to you, Flatter Day Grayson.
Well, no, let them talk, because if you guys want to see what I personally documented, I can go into that. Yep. So let everyone have.
I'm just gonna let the atomic physicist handle this one.
Yeah, so there are a lot of different ways that you can view atoms. It depends on what you mean and what you require as viewing an atom. Do you need to view a single atom? Do you need to be able to resolve a single atom as apart from a different single atom? If that's the truth, then I'm going to have to refer you to quantum gas microscope experiments, which have come out since I think like mid-2000s. Marcus Greiner's lab is an excellent example of this. And they store single atoms in an optical lattice that are separated by about 500 microns. Now, inside an actual physical solid, your atoms are the interparticle spacing between atoms, for example, in like graphene or something, is going to be much, much, much smaller than that. And you're not going to be able to resolve it just by the nature of how photons work. You're not going to be able to resolve it with photons because photons are way, way, way bigger than these atoms. So instead, you would have to use something such as an atomic force microscope or a scanning electron microscope. These are all different ways in which we can visualize, measure precisely where the positions of single atoms are. And then you can rearrange them and you can make little patterns out of them. And that's like what everybody does. Whenever they make a quantum gas microscope, your first publication always has like you always like put in like the logo of like your university or something, because it's like a fancy cool thing. And you're like, hey, I can drag individual atoms around. It's really neat. So we can see single atoms. Have I visualized single individual atoms?
You said we. You invoked we. So I was just wondering if you've done it, because I haven't.
In my personal lab, no. But in the lab next door, yes.
Cool.
So, yes,
so
I
could be a vegetarian and my neighbors could be steak eaters, right? But that doesn't make me a steak eater. And that doesn't even mean that steak's real just because they've told me about it.
If you're okay.
So wait,
fair enough.
In order for you to accept that atoms are real, are you thinking that you have to be able to see them with your own eyes?
Yeah.
Okay. Well, that's fine. I don't have anything to respond to that with. So
yeah, well, we have actual physics. We have actual physics to explain why you will never be able to see an atom with your eye, because the wavelength of visible light is so much larger than the size of an atom. No matter how sensitive your eyes are to visible light, won't ever see.
I will actually push back on that very slightly. You were correct. You were correct in the idea that you're trying to put across. But if you have a single atom trapped in an optical tweezer, and there are ways that you can know that there's exactly one, okay? If there are more than one atom, the interactions between them are going to change the energy levels, and you're not going to have your light that you're using to scatter off of be resonant with the atom. So you can know that you have exactly one atom inside an optical tweezer. An optical tweezer is just a focused laser beam that acts as a trap for, in this case, a single atom. Now, the human eye is incredibly, incredibly sensitive to certain wavelengths, like green. If you have that atom and it is able to fluoresce at a wavelength of 532 nanometers, for example, the human eye needs three photons to reliably be like, oh, hey, yeah, I see a bit of light there. Now, if you're shining a laser on it,
all right. Okay, I would definitely ask just to wrap it up there, just so we can kick it back to Flatter Day Saints.
I think we're maybe
you can trap an atom and you can scatter enough photons by shining a laser at it such that your eye would see the light from exactly one atom Exactly one.
I think we're a little too high level when our interlocutors don't even accept atoms are real.
Well,
I
sounds like
didn't
a personal
say they're
problem.
not real. All I'm saying is that I'm looking also at a lot of different sides of stuff. So they very well could be. I'm just saying some of that I do feel is coming into question a little bit. But again, I'm not like that's not my area of expertise. I'm more looking at the heliocentric model side of things more than.
Okay.
Well,
you've been saying that you're going to bring like
Oh, yeah,
evidence that the heliocentric model cannot exist or something. So I've been curious about that if you got it.
Yeah, that's fine. We could do that now. Let me screen share here.
Sure thing. Here you go.
And can you guys see that? Okay.
Yep.
We can all see that. Yep.
All right. So can we all agree on this definition that a full moon only occurs when it's 100 degrees opposite the sun?
180, and no, I don't agree with that.
So that's what it says right here. When you Google it, it says the moon is exactly 100. It says how, let me read the definition then that astronomers accept. A full moon is opposite the sun in its orbit around the earth. Its sunlit side is entirely visible from Earth. The moon appears full to the eye for 2 to 3 nights. However, astronomers regard the moon as full at a precisely defined instant when the moon is exactly 180 degrees opposite the sun in ecliptic longitude. So you do not agree with that definition?
What I disagree with is the idea that full necessarily means what the astronomers are defining as full, as opposed to what we typically define as full. Something can be, if the moon looks 99% full, if it's a gibbous with just 1% of a thing, you're not going to notice that, and it's going to hold on. It's not going to be, so it's going to still appear full, even though if you had a more reliable, more precise measuring apparatus like a telescope and you were an astronomer, then you might not categorize it as full.
Okay, so I'm going to go forward instead and just read standard definitions because I think that's going to be a lot easier. So the way astronomers define a full moon is when it's 180 degrees opposite the sun. That's when it's at 100% illumination by definition. The definition for when a lunar eclipse occurs is only at the full moon phase. So when it's at 100% illumination. These are just standard heliocentric definitions. There is absolutely zero controversial here. Okay, so now I'm going to share what I've documented personally on many, many occasions. I'm going to pull it up a second here, because we're asking about personal experiments and such that we've done. So let me pull this up real quick here. Sorry, it takes me a minute.
Yeah, Polaris.
So, can you guys see the screen okay?
Yep.
You're ready to go.
Yeah, I would call that full, for the record.
All right. It is December 13th, 2019. I am in Temecula, California. As you can see, the moon is at 97.6% illumination. I'd like to show you right up there is the moon. You can see it.
Can we pause it?
The mountain ranges there.
Oh, there it is. Sorry, found it. I found it.
And directly behind me is the sun above those trees and buildings right there. So, according to the heliocentric model, that moon should be about 100, actually over 175 degrees around the globe model Earth. Now, my puny little body cannot see beyond the curvature of the alleged globe model Earth. And that thing is supposed to be on the unlit side of the Earth, 175 degrees away from that guy. And yet there'll still be people who will say dumb things like refraction. I'm sorry, but look how high that is above the mountain ranges. Moisture in the air did not bring that moon from the unlit side of the globe model Earth directly in my line of sight simultaneously from Temecula, California with the sun. It's just not possible. So that's all I got to show on that. And there's another one. It's called a
can we address that one first?
Yeah, let's talk about that for a few minutes. And I just want to remind everybody, I mean, we got 16 minutes, well, just a little bit over 16 minutes of open discussion left. If it goes a little bit over, that's fine by myself. You all know that. But I just want to remind everybody, I see that there's about 400 odd of you kicking around in the live chat there, almost 500 now. Hit the like button if you haven't already. We really appreciate it at Modern Day Debate. Share it out in those spaces where you like to have these debates. And let's keep it rolling. So let's respond to what we just saw there, gents.
So, you know what I didn't see? I didn't see a measurement of any sort other than, hey, look over there and then look over there, which, you know, is better than nothing, I suppose, of what the actual angle was. Because that looked like 175 degrees to me. How wide is the moon, angularly?
I don't know if you've ever played pool, but 180 degrees is when 3 pool balls are lined up in a row. 5 degrees over is a minor movement. You're saying something that was 175 degrees around the Earth from the sun?
I'm saying that it looks consistent with that to me. Yeah, the moon is how.
I don't know how to respond to that.
Well, I know.
I just have a question. Why wouldn't you expect the moon to be in that position? I don't get why you don't think it should be.
It's not where I expect it to be. It's what the heliocentric model depends.
That's what I'm asking. Why do you think
Bro,
that the heliocentric model would tell you that observation can't happen? Why do you think that?
Because the phases of the moon work like the hands on a clock. A first quarter moon is like 3 o'clock. A third quarter moon is like 9 o'clock. A full moon is like 6 o'clock. A new moon is like 12 o'clock. It's like kindergarten, going back and learning the phases of the moon. That's how it works.
The difference is that a clock and a pool table are 2-dimensional. When you're talking about 180 degrees, you're talking about 2-dimensional things. This is a 3-dimensional system, right? You can't just make an analog for a 2D. But my point is that we can predict when lunar eclipses are going to happen, right? You would accept that. We have mathematical models based on like the way that the planets and the moon and the Earth all move in the solar system. We have models that are capable of predicting to the exact down to the minute when lunar eclipses will occur. So
it's based on the solar cycle, bro.
There's an astronomical clock in Prague that still documents those type of events. They've been documenting lunar eclipses for thousands of years. The Mayans have done it. The Chinese have done it long before they had modern heliocentrism. So how did they do it if they didn't have the globe model Earth?
They did have the globe model of Earth.
The Chinese believed that the Earth was a spheroid, 24,901 miles in circumference, flying through a vacuum around the sun. Show me proof of that. That's not
I didn't
true.
say that. I didn't say
that. They predicted lunar eclipses. So did every culture. Know why? You know how lunar eclipses work? They're cyclical.
I am very familiar.
They're cyclical. You don't need a big spinning ball for them to operate. They're cyclical.
Okay, so you're saying that you had predicted that. Okay, you think that the heliocentric model would predict that observation that you just showed is impossible. But I don't see where you've justified that. I don't think that your understanding of what the heliocentric model would predict in that situation is accurate.
No, you're demonstrating that you... Okay, tell me this then. If we're debating the moon and the heliocentric model...
We're debating the flat Earth.
Okay, the flat Earth. That's all tied into it. We just talked about atoms in quantum physics, okay? Like, tell me this without Googling it. This is a simple question. What degree of tilt does the moon have above the Earth's ecliptic plane?
I don't know off the top of my head.
I think it's about 5 degrees.
Boom.
Above the Earth's ecliptic plane?
Yes, you got it. Okay.
Yeah, okay.
See, But that's what I'm saying. You're saying that why would I predict the model does that, but you don't even know like a basic parameter of the motion within that model. That's a simple parameter.
It honestly seems like a non sequitur. Like if
also, I did know,
like
for the
if
record.
I don't
I'll
know,
give you a better one.
If you're hold on, if you're gonna call out your interlocutors for not knowing an irrelevant fact, you should make sure that neither of them know the irrelevant fact.
No, I gave you credit. I thought that was awesome.
I know, but
I'm not trying to attack anybody. All I'm pointing out is that I have deeply studied this as well. There's no reason to laugh as though my knowledge is inferior to your knowledge. I've also studied this greatly in depth. I didn't just decide one day, oh, the Earth's flat, so I can be different. I don't give a shit about that, dude. Like, I believe it because of all the experimentation. I'll show you a greater one from observable reality than that one if you want. I'll show you a better one.
If you think that's 175 degrees, I do, and I can make my argument quantitatively.
Yeah.
How wide? How large is the angular size of the full moon, roughly?
You agree that to be looking
How large is the angular size of the full moon?
I don't know that.
It's about half a degree. Okay? So 175 degrees is going to be 10 moon diameters away. I may have said radii before. I meant diameter. Is going to be 10 moon diameters away from a perfect 180. Now, in the image that you showed, that looked like if you tiled the moon 10 times and brought it down by factor of 10 moon sizes, that it would pretty much be right on the horizon. So yeah, it looked like 175 degrees.
Yeah, no, you're not understanding. It's supposed to be 175 degrees around the Earth from the sun. They're both above the horizon. The horizon maximum can be 90 degrees. You understand that, right? If I'm standing on the surface of a ball, the horizon can be max 90 degrees. That moon should be below my feet. In an angular sense, it's supposed to be 175 degrees around the Earth from the sun. So then if that's the case, then how do you see that exact same illumination in the middle of the night, not next to the sun? If you can see them right next to the sun right there at 1 minute when it's 175 degrees away at that percentage of illumination, why have I also seen it in other positions in the nighttime sky? In all different positions.
Because the Earth is not obstructing the sunshine from hitting the moon in that scenario. I mean, you should be aware of that. I mean, when you're saying, why can I see the full moon when it's nighttime outside? Why do you think that anything would be obstructing the sun from lighting up the moon when it's nighttime? There's no Earth that would be obstructing that view.
Because it should be 175 degrees away from me underneath my feet. I'm not understanding how you... Like, okay, so why doesn't the sun sometimes pop up in the nighttime sky? If the moon is... So when I've seen the full moon up during the day...
Okay, wait, hold on. Before you go on...
Let's let Mike wrap up his point there.
Yeah, let me say this.
15 seconds.
If the full moon... If I can see the full moon, right, up in the sky with the sun when it's supposed to be 180 degrees around the Earth in the nighttime sky, why does that never happen with the sun when it's supposed to be on the opposite side of the Earth? Why does it never, due to refraction or whatever excuse, why does it never show up when it's in the nighttime sky when it should be set? How come only the moon is...
All right, we have to let Grayson respond to that there. So over to you, Grayson.
Yeah, it's because it's being obstructed by the Earth. But like we're saying, what you observed in that video was 175 degrees. Look, this is 180 degrees right here. This is 90 degrees. You're saying
the middle of your...
You literally looked at it at 175 degrees like that.
I can't do it.
That is what you observed. The sun was over here. The moon was over here. 175 degrees separated.
This is what it looks like, right? I'd be standing on the lit portion of the Earth. The moon should be opposite of it. Yeah. How can I be looking upward angle at both an upward angle from the surface of the Earth, and you think that's anywhere near 180 degrees? How?
in your video, right? Just
Yes.
when you're wait, hold on. When you're standing and you look at something on the horizon and you turn 180 degrees and you look the other way, exactly like you did
I'm
in
not
that
saying
video.
turn around and see it. The objects need the earth between them. The earth is the middle point, not my eyes. The observer is not the central point. The center of the earth is the central point. That's what you're misunderstanding. You're using me as the observer, and yes, see his drawing? That's not accurate.
Can you maximize Tapioca's screen?
So we got the sun.
Yes, that's my
I don't know
point.
if I'm.
You're
I don't
not
know
understanding.
Bro.
Well, maybe people can see it the way it is.
We got the sun, okay, which is spelled totally wrong. And then over here we got the moon, and then we got the dude here. He's chilling on Earth, right? And none of this is to scale. This distance is not going to be the same as this distance, even remotely. But my point is that you saw the moon way over there. This is a 175-degree angle, which
as the observer as the middle point, correct?
Yes, that was.
Yes, so that's
the
not the model.
Was the guy with the camera.
The model says this.
This is exactly what the model says, bro.
This is what 180 degrees through the Earth would look like. That's what it should be. You see this darkened side of the Earth? That would be the nighttime side of the Earth. The moon at 180 degrees would not be opposite. God. You're using the observer as the reference point.
Absolutely. Yes, bro. The observer is the guy who's making the observation.
So if I'm this observer at the top of the ball, you think I'm looking at a downward angle at the moon in that video?
No,
you think I'm angling look at the man standing on the earth in the picture. You're trying to convince me that my camera was pointed downward at the moon in the dark side of the sky. Well, then where are the southern stars? Why aren't those there too? Why can I only see the moon? If I can see that far around the earth, where are the southern stars too? It shouldn't just be the moon.
The sun is out, dude.
It's nonsensical that this
the sun is out.
Sense,
you wouldn't see the southern stars. You'd see the stars for whatever's appropriate for you to see. Okay, you can totally be standing at the North Pole, for example. You're never going to see any southern stars, but you can totally still see at the right time of year the sun right near the horizon, and the moon also right near the horizon. That's 175. It's 180 degrees. Your diagram is even more out of scale than my diagram is. That's why it doesn't make any sense.
Okay, well,
that's true. Yeah, sorry.
So I have a question so you're saying that was 180 degrees, right? And I'm not going to argue with you over that, right? But is it 180 degrees when there's a full moon and the sun passes in front of it, or the moon passes in front of the sun for an eclipse? Is that at a 180-degree angle too?
No, that's a 0-degree angle.
The moon, maybe.
A solar eclipse happens with a new moon, not a full moon. Did you mean lunar?
So there's never a full moon where it's eclipsed?
Lunar eclipse.
Okay, so is that 180-degree angle?
The closest you get to a precise full moon would be in a lunar eclipse, yes.
Okay, so during a lunar eclipse, is that a 180-degree angle between the sun and the moon?
Yep.
Well, since both of these things are of finite size, you're going to have error bars on these. Also, measurement capability. That's actually the reason for the error bars. The finite size is, I mean, I suppose if you chose the center point of each one, it's going to be, it's going to go through 180 degrees if it's a perfect, full-on, absolutely aligned lunar eclipse.
Close enough to 180.
Yeah.
I have another question real quick. So you were talking about if you dug a hole through the earth, you'd end up in Australia. That's what you said. So I'm just wondering, at what point, when you're digging that hole, at what point would you reverse so the blood would no longer be rushing to your head, or raindrops wouldn't be going opposite through the earth up, going the opposite angle of raindrops on the side you started digging on?
Okay, it was an imaginary hole to make the point about what an antipode is. If you were actually going to do that, you would die way before you ever got anywhere close to the core of the earth. But the core of the Earth is at what point up, like down would be up, and it would flip at the center of the Earth, going the other way. Because
so the blood would no longer
you
be
would
rushing
never.
my head.
To be clear, you would never get there because it would be too hot and too high pressure.
When would blood rush in your head? When? What are you asking about?
When you're upside down, blood rushes to your head, you know?
Okay.
Yeah.
Yes, I follow.
So,
when you're upside down, blood rushes to your head.
yeah.
Okay.
So if you
unless you're falling, then it doesn't, because all of you is falling at the same rate.
So if you're falling from North America all the way down to Australia through the Earth, right? When would gravity kick in once you hit Australia? So you'd go like that? How far up would you fall down to Australia if you came through right there?
This cannot be a serious question, but I mean, you haven't mentioned.
I'm just going off of what you said.
Again,
I'm just elaborating.
I clarified what I was talking about was just to illustrate what an antipode is. I'm not saying anybody has dug a hole through the core of the Earth. I mean, I'm not saying
because they haven't. Yeah,
they have not. Correct. I just said it's too hot and too high pressure. We don't have technology to do that or make that viable.
So it's a theoretical story, right?
No, antipodes are real. I'm just saying an antipode is just the opposite point on Earth, as if you were to dig an imaginary line all the way through, you would come out at the antipode. I'm just illustrating what an antipode is.
How about something you could experience? Like if a plane took off from America, at what point would the plane flip upside down before it got to Australia?
That is nonsensical. That had never happened. That is not a part of the globe or the heliocentric model.
No
model thinks that.
Welcome to flat Earth, bro.
No.
Welcome to flat Earth.
No.
You just proved my point. Thank you.
No, the globe model does not say that. That you are misunderstanding what the globe model would even predict for that in that scenario.
You wouldn't have to predict. Look, shouldn't it? You said have to predict anything. There's flights every day that go there.
Hold on for a second. I brought up actual measured empirical evidence showing that the antipode does have measured significance with antipodal focusing. That shows that the antipode is not just some arbitrary point on the flat Earth. It has actual measurable, verifiable significance.
Well, I'm asking you measurable things. I'm asking you at what point does the plane flip upside down when you go to
Australia? It never flips upside down. Nobody thinks that. That's not a prediction of the
flat Earth. Thank you.
No,
so if the plane never flips upside down, that means it doesn't go to the bottom of a sphere. It never flips upside down.
No.
You know what does flip? You know what
you
does
made my
flip?
point. Thank you.
You know what does flip? The direction of what down means. That does flip.
Does it?
So because it's a sphere.
At what point does it flip?
Going here.
Where exactly would it flip?
It flips continuous. It continuously changes because down is always pointed towards the center of mass of the Earth. Well, actually, down is always pointed towards the center.
It's close enough to say the center of mass.
It's close enough to say you're right. I shouldn't. I do this all the time. I want to be like exact and precise, and then I make things more complicated than they need to be.
Yeah, it's close enough. It's the center of Earth. That's the direction that down is. So if you're asking me, maybe I misunderstood your question about the plane flipping. You're talking about at what point is the plane upside down relative to where it started? Is that what you're talking about?
Exactly.
Oh.
Yeah.
So
from
the
time it reaches Australia.
As the plane travels, it's going to be going like the direction of down is always going to be perpendicular.
Yep.
Close enough perpendicular to where the plane is moving. So as it goes,
and perpendicular is the opposite of horizontal, right?
No, vertical is the opposite of horizontal.
Perpendicular is not the opposite of horizontal.
Vertical is perpendicular. Yeah, vertical is perpendicular to horizontal. Yeah.
Yeah. Yeah, that's the opposite. They're intersecting.
Yes. That's how you define.
Does perpendicular ever bend, or is it usually a straight line?
It's a straight line to the center, which obviously, as you travel on the Earth's surface, that straight line points in different directions, and this is measurable in land surveying.
Oh, so when they use a plumb bob, right? When they're getting
Yes.
Welcome to flat Earth. Shirts in the back, snacks on the way. Thank you.
If you have a very, very, very tall plumb bob from two different points that are, say, 100 meters apart, and it's long enough, those are going to be at an angle. They are going to be at an angle.
Experiment where that's the case.
You know what? Okay, I will, because you know what? they do this in LIGO. In LIGO, you have two extremely long interferometer arms, and they have crazy over-engineered mirrors to go down in there. So you've got this long tube. It's like 4 kilometers long, okay, between two things. And both of those mirrors have to be pointed slightly downward from straight horizontal according to the tangent line relative to gravity at that point. So
you just invoked horizontal. Horizontal is a flat surface. It's flat. Horizontal's flat.
Yeah, and do you notice the context in which he invoked it to say that the mirrors are not tilted. Parallel, they're tilted compared to the horizontal, and that's exactly because
they're parallel to each other, but they're tilted compared to the vertical.
A straight vertical would not be parallel at that distance. They would be pointed in slightly different directions, even though each line is vertical.
It wouldn't be straight.
What,
then it wouldn't
be straight.
What
the distance? Can I ask what the distance is?
All right.
What's the distance? Yeah, what's the distance?
He'll come up with that for a second. But I want to say, in addition to LIGO, literally any book on like land surveying will show you mathematically how surveyors actually account for this difference and how you can measure it yourself by looking at very tall things near you. And you can measure this, okay? All you need is a theodolite. But literally, when the farther 2 points get and they're vertical as measured like by a plumb line, they will not be parallel, and they will become less parallel the farther away they are. And this is observed in land surveying.
No,
I have the stats.
It's absolutely not observed.
I have the stats.
It should happen. Okay.
So LIGO, the arms, as I said, are about 4 kilometers. Now, 4 kilometers corresponds to, assuming that this is correct, and it seems reasonable, and you can check me if I'm wrong, 1.26 meters. Now, that means that at the middle, I think you have to divide that by 2, roughly. Maybe 4, actually.
Do you mean miles?
At meters. 1.26 meters is how far for example, the 8 inches per mile square, if you were to plug that in over 4 kilometers, I think that you would get the 1.26 meters. What that means is that they have a big tube, and at the end, they have the mirrors at a certain height. And then they have the light traveling a straight shot between them. In the middle, the height of that laser beam is significantly lower than it is on either end because it's going over a shallow spot.
You're saying the light on the laser beam bends?
No.
Categorically did not say that.
What he's saying is there's a measurable hump in the light. And it's about a 2-mile distance that they're doing this experiment over. So the hump would be pretty negligible. What's great about my website on Flat Earth Archive is I have multiple laser experiments between 3, 7, some up to 12 miles, showing that the curvature that should exist doesn't. So if they're measuring it with mirrors in just 2 miles, imagine how much greater it should be in 7 miles and in 10 miles. And I can show that it doesn't exist. There's experiments demonstrating that it doesn't exist.
I highly doubt that you can show that.
It's all on Flat Earth Archive. Go look through the video section. There's laser experiment.
I do not doubt that.
Experiment.
Well, I doubt that they are in any way
everyone remember that their experiment was 2 miles. Go reference the distance of the experiments that you see on my page, and they're all videotaped.
Okay,
they're not in a tube. They're not in a tube that nobody can see. They're right out in the open, verifiable and documented.
Now, just reference the precision and mathematically precision of the LIGO experiments versus the precision of you with your lasers and cameras.
They're astonishing.
I
they have
my lasers.
I am going to jump in here, guys.
They
just for 1 second.
GPS guided laser system. They built a $20,000 laser to conduct this with. My lasers and cameras, you're mocking something you haven't even seen.
All right, I'm going to jump in here. Just hold on, Grayson. I don't want to start the muting process.
It is.
I want to let you know that we have reached the end of our 50-minute discussion. I don't mind letting you guys carry on, but this is a point of, respect for the other speakers in the room. If you guys need to take, a little break, or if you need to grab a drink, that's fine. But let me know, each and every one of you, if you need a break or if you would like to continue with the open discussion, go into Q&A.
Can I get like 3 minutes? 2 minutes?
Yeah, sure. If you need a break.
That would be great.
All right, excellent. That's no problem. That's why we let our speakers know, because sometimes we talk for a little bit longer than we plan, and you know, sometimes we need to use the washroom and, you know, grab drinks and whatnot, or we get really hungry. Oh my goodness, we get hungry.
Don't forget to wash your hands and sanitize them.
We don't want to be sitting there going.
Cleanliness is next to godliness.
Well, I will let you know, guys, we are going to do our Q&A here. I think that there may be a bit more open discussion coming up after this. I know that Grayson had another, I can't remember the name of it, Grayson, because I have to be honest with you, it kind of slipped me, but there was another thing that you brought up in your opening argument that was separate from this that we didn't really get to touch on, I don't think. So,
we kind of talked about the antipodes just a little bit.
Okay. Oh, as long as you guys are satisfied.
Remember, they conceded on 2 points that I made already, so I'm just saying.
Wait, which points did we concede about?
You conceded about the point digging through the earth, and then rewind the tape on the other one.
I don't know how that's a concession, because it was never my claim that we've dug all the way through the earth. So how can I concede on something that I never made?
No, but you said if they dug through the earth.
Yes. Then I didn't.
So then I said
that they would get out of
the story.
If you dug all the way through the earth, you would come out at your antipode, and I don't concede anything about that. Antipodes are real and they exist, and I demonstrated in my intro that we measured that.
Most people watching probably don't even know what that is, but I'm just speaking in layman's terms, right? So since I don't understand what that is,
speaking of people watching,
let's just say that
I explained it several times what it is in my intro.
I'm playing devil's advocate.
I tried to be very clear and use basic language so everyone can understand what an antipode is.
Well, let us wait until.
So aren't you taking your demonstration or what you were saying, your example, all the way to the end of it?
What are you talking about? What have I not carried all the way through?
Well, when I said, well, if you did dig a hole to Australia, at what point would the blood be rushing your head? Would you be upside down? At what point would raindrops be going the opposite of the other raindrops on the other side of Earth?
I already did answer.
Well, we can't really dig all the way through the Earth.
I already answered that. It would be at the center if you could somehow control for the temperature and pressure.
You conceded. Thank you.
That's not a concession at all, for the record. So you just said, you know, cleanliness is next to godliness. I'm pretty sure God doesn't really appreciate lying very much. So you probably shouldn't lie and say that I conceded when I'm telling you I did not.
Well, I'm going to object here just before we go into, maybe we'll get some more open discussion. We're going to check with everybody once everybody's back. But I do want to let everybody know, if you haven't already, hit the like button. It helps us out in the algorithm a ton. I don't know what's going on here. We got 500 people watching. Do you have fingers? You know, sometimes when I'm laying in bed, you know, I can click things with my nose. You know, I can be that lazy. What's going on with you guys? What's happening here?
Let me just ask the chat really quick. I could do an after show on my channel after this. So if anybody in the chat would be interested, let me know and I can set that up. So, well,
I was going to say, it looks like, I'll read one preemptive. Dr. Dino for $5 says, setting up an after show for this fun little discussion. Open mic for anyone who wants to join. Gonna have some Kerbal Space program in the background. So your old pal Mike, Flatter Day Saints, Base Theory, and once Dr. Tapiocaweasel gets back, we'll let him know that Dr. Dino is setting up an after show, so everybody will be invited. I'll get you all the link for that if you want to hang out there afterwards.
And I love Doc, so I'll let him do the after show. I'll probably be coming through and saying hi to everyone. So.
Awesome. Well, we'd be happy to see everybody there. It's always fun to see everybody at the after show. It's really simple to follow the link and get into the after show. So hopefully we'll see you all there. But I want to let everybody know who's watching right now. Once again, hit the like button, and I'm gonna check with you guys. Was there any other open discussion that you guys wanted to flesh out before we hit that Q&A?
I have ADHD. I've forgotten.
He's forgotten everything, everybody. All right, well, cast your votes in the poll. We have it in the chat right now. Get your super chats in, as they will be read with priority, and will probably be the only questions read because we got quite a few super chats already. So let's get that rolling. LJ.
Really? Oh, we get a cut? Really quickly, if I could just pose...
Coming at us like that. Hold on now. Go ahead, Grayson.
If I could just pose the question that was in my intro to the flat earthers here, like, I'm just curious how you personally think that a sun sets on a flat Earth. Like, what is your explanation for why that occurs?
This will be my chance to step out.
Because light has a limited range, so the size and distance of the sun would make that light not carry across the whole surface in the models I've looked at. I'm one of those that it, like you brought up, it doesn't ascribe to an exact model at this point. I feel like there are too many unknowns, but it just doesn't make me accept a false model like the modern heliocentric model. I won't settle, but I don't pick or ascribe to a specific model at this point.
I ascribe to the zodiac model, where Aries is the beginning of the year and it's a perfect clock. So whenever you guys say, is it round or flat? It could be both. Like a coin is round or flat, or a dartboard or a clock is round or flat.
But how does the sun set?
So if I were to tell you that, that would just be my belief, theoretical. You know what I mean? It wouldn't be anything factual.
That's what we're talking to you to interact with your beliefs. Like that's all any of us have is our beliefs.
There's two really good videos on my channel. One is entitled "The Earth is Not 93 million miles away." It's where a gentleman uses AutoCAD and the angles of the sun from timeanddate.com and shows that even giving handicaps to the heliocentric model, that 93 million miles away is not even an option for an angle on it.
That
and
actually sounds
also another video that's just time-lapse footage of the sun, so you can compare observable reality to what heliocentrism teaches, which I think is important.
The way I see it is like this, bro. When the sun rises and sets, it's bigger and not as bright as when it's overhead and smaller and brighter. So you could take a flashlight beam, shine it at the wall, and adjust the beam. If the beam's bigger, it's not as bright. And the smaller the beam gets, the brighter it gets, just like we observe the sun being.
So
it's just a light. In my opinion, it's just a light. It's not something tangible you could actually physically go to or touch.
So then what is it that when the sun is halfway set, so the bottom half is obscured, the top half is not, you're claiming that the top half is close enough that we can see it and the bottom half is too far away so we can't? Or if you're not claiming that, what is it that is obstructing the bottom half of the sun? Why doesn't the bottom half of the sun's light make it to our eyes?
Well, I've used a P1000 and zoomed in on it. And so when the sun appears to be, where most of it would be obscured by what you guys call the horizon, I've zoomed in on it and it's a perfect oval shape. And I see the bottom of it too.
Have you had a filter? Has the edge been crisp? I don't think so.
I've always. So you guys were talking about filters earlier. The picture he showed of the sun. How do you know there wasn't a solar filter on it? What cameras have you used? What experience do you have with cameras?
There wasn't a solar.
I know. I'm just saying. I'm asking them what experience they have.
I will answer that. Yeah, it's because when a solar filter is applied, you can very, very clearly see that it is, because none of the other stuff is visible. Like everything is blacked out.
What cameras have you used and what lenses have you used with a solar filter? Just out of curiosity.
I've seen plenty of shots that have solar filters and those that don't have solar filters, so I'm aware of what solar filters look like when they're applied to a camera.
All right, Mike's.
I know how a filter.
Yeah,
Mike's trying to get in here, everybody.
To
Let's
answer your
speak.
question, to give you
just 1 second there. Before we get, if you can hold that thought for 1 second, Mike was trying to speak all throughout that. I wanted to give Mike a chance here.
I would just say that. The reason, so there's two different things. Obviously, one of the videos I showed at the beginning, that when the sun disappeared from view is still above the horizon. So obviously the, is obscured from visibility due to the atmosphere. And so when we see an optical illusion, like over the ocean, where the bottom portion is getting obscured, well, we know that the closer you get to the surface, the denser the air becomes, so we get more refraction there. So you get more obstruction due to the density of the air, the level of moisture. So that's where I would say that occurrence comes from.
I love it. I love that answer. I would love for you to go into details. I would love for you to give me a profile of the humidity, the pressure, and ultimately the index of refraction as a function of altitude over this distance, and show the calculation, show how when you integrate it through, this is the path that the light takes. I would love to see something like that. Because what you just said is precise and quantifiable. Bring receipts.
Yeah, I do, and I do. Let me see
I
if
just
I
add
got
one thing
it.
to that really quick, is that if you have like a medium where you have like more dense at the bottom, less dense on top, which is kind of what you're talking about, then the refraction would be like bending it up over.
It would
wouldn't
make it,
be, yeah, it would carry it
look
further.
higher.
Yeah, it would carry it further, not obstruct it from the bottom up.
Depends on the position of the sun, right? If it's coming at you, it'll do one thing. If it's going the other direction, it should do the opposite. It should handicap you. And I have footage of things where the sun should be handicapping you because light should bend towards the more dense gradient. It bends towards the more dense gradient. And there's examples where there are objects at distances further than when they should be seen, and the light should actually be probably working against you, if anything. And that's my problem. Like, I don't hate the globe model Earth. I was raised to believe it, but I just seen too many things that like I cannot unsee is my problem.
But it sounds like
I spent a lot of time on 4chan too. It's rough.
It sounds like you have a
what that
relatively
is.
sophisticated understanding of refraction, so you should understand exactly why we can see those things because of refraction. I mean, if you have a mathematical understanding of this, then you could do the calculation yourself with the known lapse rate that you could measure, and you could know how far you should be able to see due to the refraction conditions.
Yeah, and there's an experiment. I was trying to pull up the image on my website, but it's called the greatest series of laser experiments to this point in history, testing the convexity of the Earth's surface, and they do all that. They do it in multiple locations, so not the same location, different times of year, so under different amounts of humidity. They calculate it all in, and they even show the type of laser they use and show how much refraction is expected from that exact product. There is no more in detail experiment on Earth, and it was conducted in 2022, I think it was. I have it on my page, and there's nothing more precise or more detailed than that series of experiments that took a few years in the making. There's nothing more precise than it. And they take into all that. You can watch it. It's an hour long. You got to sit through some dry, boring crap. That's why people don't want to watch it. It's boring. There's nothing exciting about trial and error and all that, but it's there.
So can I just ask you, what makes you qualify it as the greatest laser experiment ever done? I mean, are you aware of every laser experiment that's ever been done? Or like, what makes you say that it is?
The reason is because I can compare it to institutions like the Discovery Channel, that is a pretty top-notch channel.
Compared to LIGO.
What?
I mean, LIGO was a laser experiment.
Yeah, and it's
Discovery Channel is not a scientific organization.
All right, everybody.
Let me answer that. We'll
let you answer that, but then Tapiocaweasel's been waiting to get in here, guys. So let's. I'll give you another 15 seconds there, Mike, and then we got to let Tapiocaweasel respond because he's been trying to get in here too.
Yeah, I'll just say that. What was I going to say? I kind of lost my train of thought.
Why was it the greatest?
Never mind. Scoot on. What was it?
Why was it the greatest?
Oh, because I've seen because when you're debating this kind of stuff, you get a lot of attack, right? People throw their best things that they possibly can at you, which is appropriate. I feel like that's good. I think every position that we have should be scrutinized to its deepest extent. So I don't fear scrutiny. So I feel like with my page, you could probably imagine a lot of anger, a lot of proofs coming my way. So I would say that I've probably seen the best stuff that the globe has to offer. And when I weigh both sides, I can't believe in the globe model Earth. That's why. I don't see a better, more detailed experience. You watch it and you prove to yourself then. That's what everyone should do. You prove to yourself. You watch that series of experiments, and then you go out and watch other lasers experiments, and you tell yourself which one looked the most detailed.
All right, Doctor, let's get it in here before we go into the Q&A.
Yeah, I have a PhD in experimental atomic physics, which involves a lot of precision laser work. That's how you talk to the atoms. You have a vacuum chamber, you have a few atoms in there, and the only way you talk to them is by shining light of exactly the right color on them. That's like 95% of what you're doing is that, and the steps you got to take to get to that. it's very precise work. I'm very familiar with how lasers and laser experiments work. I will absolutely take a look at what you have challenged me with, but dude, you said that you use the Discovery Channel as an example of a scientifically reliable source, and I don't. Were you trolling me?
No, that's what I felt like they were doing to me. They did a laser experiment.
They are trolling. They are the Discovery Channel is trolling you. Yes, you're absolutely right. They're full of it.
Wait.
They're
You're telling me that there's no ancient aliens?
It's stunning. I know. But no. The Discovery Channel has never ever been a reliable source of scientific information. It should be.
Stephen Hawking was narrating for it.
They probably pay really well. But
all right. Well, what I'll say with that there, everybody, is I think it's a good time to move into the Q&A, just because Q&A will spur a lot more discussion. I feel like this is going to be one of those late ones, everybody. As long as everybody consents to that, I think that's probably the direction we're going in. So I just want to let everybody know, of course, that we do have DebateCon 4 coming up. So if you have the means to be there, we would appreciate it. We'd love to see you there. As far as I know, I'm going to be there, along with, of course, if you see all of our upcoming events, the order of people that are going to be there so far. So lots of great speakers. You won't want to miss it. So check out the link in the description. And of course, the other thing as well is, if you missed it, Matt had a discussion with Perfect Dawa, and just like a lot of discussions on Modern Day Debate, they sometimes become podcast exclusive. That's right. We're on all the major podcast platforms. So if you're a big podcaster, if you're like, I like running and listen to my podcasts, check us out on whatever app that you like listen to your podcasts on, because we're all over the place, and that's where you're going to find this debate that you see beside me right here. So go check that out if you haven't already, and we're going to kick it into our Q&A, everyone. Thank you so much for being here. Over to the Q&A. We're gonna ask some questions. LJ. Well, we're going to clean that up. Globe peoples, believe me. Globe peoples believe the ISS is traveling 17,500 miles per hour to all guests, and the Chad moderator. I think that's what they meant. Would you ever get on a roller coaster that would go 17,500 miles per hour?
I don't even get on regular roller coasters, so no.
I second that. I'm very squeamish, like, oh man, I can't do like amusement parks or like spinny things. Oh, the worst. Roller coasters? No, thank you. I'm out. What do you think over there, Latter-day Saints?
About roller coasters?
Yeah. Would you ever get on a roller coaster that's traveling at the speed of the ISS, which is at 17,500 miles per hour? And they're saying that
this is the equivalent of that. Imagine taking a GoPro, gluing it to a basketball, then getting on a roller coaster and spinning the basketball on your finger, and then viewing what you see. You'd see something different every single, however many times you went on the roller coaster, you'd see a completely different scene, right? But that's not what we observe in the sky.
Because the Earth is bigger than a basketball. Do you understand how much bigger the Earth is than a basketball? Because if you did understand that, it would answer your whole point.
So Earth really big, we really small, right?
Yes.
Like ants? Got it.
I mean, much smaller.
No, ants would be even smaller than us, but okay.
You're off by several orders of magnitude. Anyway, my answer is maybe. I don't know. It sounds like an awesome ride. I'd have to have more information. Not with current technology. That would be absurd.
All right. Well, let's get into
current
the
technology.
Oh, you want to have more comments there? We'll continue on.
What is this? A school for ants? All right.
So when they're on the ISS going 17,000 miles per hour, but they look like they're going slow, like underwater, the RPM of their socket wrenches, when they're putting bolts in or whatever, they're doing work on the ISS on a spacewalk, it's going the same RPM it is on Earth.
Do you
So
understand?
that's one of the
Do you understand what the equivalence principle is?
So slow. I was going
So,
slow.
like in relativity, right? If you're moving like in a spaceship going really fast, there's not an experiment that you can do inside the spaceship to differentiate your acceleration versus like gravity field or anything. Like the things that are inside the spaceship are all traveling at the speed of the spaceship. So you don't
I'm
observe
talking about on
any
a
weird
spacewalk.
effects.
When they're on a spacewalk, they're on a spacewalk
Yeah,
outside the spaceship.
they're still traveling at the same speed as a spaceship.
But there's
Yeah, I understand that, but it looks like they're going super slow, right? But yet the RPM on their socket wrench is going the same speed as is on Earth. It's not
Why
slowing
wouldn't
down. So that's the
Why would it not?
inconsistency.
Maybe.
So if
I don't
they're
know.
slowed down, the people's movements are slowed down, why wouldn't the RPM of the socket wrench be slowed down?
Because the
How would
motor
that be
is
the
still
same as on
going.
Earth?
The motor's still getting the same power. It's still going the same RPM.
Time doesn't slow down. Time
But
actually
people
speeds
slow
up.
down. It
It's
shows
tiny.
people going super slow on a spacewalk, slower than they would on Earth.
Yeah, because
They're
they're
moving
being
like they're moving
cautious.
underwater.
You know what happens? You know what happens if they float off? Well, a tether catches them. But if that breaks, then they just go woo out into space forever. It's a horrible way to die.
If you're on a spacewalk,
because
you're
if they
not going
died
to
in
be trying
space,
to
they'd
hurry as
explode
fast
and
as you
implode.
can.
Mike,
They'd freeze and burn up at the same time.
Mike, you've got some thoughts down there. I haven't heard from you. What you thinking there on that question?
Oh man, you come to me right when my brain blanks out every time. Oh, I would say that when it comes to relative speed, right? You know, where if an object's already going that momentum, you know, you're essentially not going to feel that speed. The thing is that within heliocentrism, that's another hard part about it, is that in that model, objects wouldn't be keeping a consistent speed. They'd have to continuously decelerate and accelerate.
Why?
Because when you're flying, when say like the Earth is going around the sun, correct? In most models we see, they just show us a Newtonian model. They show the sun stationary in the middle, and they show the Earth and all the other luminaries traveling around it. But what their model requires is actual additional motion from the sun. And also when these alleged satellites would be orbiting, they're going to be passing different positions of the Earth's motion at different times. So to keep a consistent distance, its speed would have to accelerate and decelerate depending where it was in its orbit. And that would be very noticeable, but you never see that because it doesn't happen, because all that NASA stuff is just
Why do you think that would have to happen?
Well, because people have mapped it. People have made 3D models of the motion, because all the motion's documented for the heliocentric model. You can look up the speeds, their trajectories, their distances. Yes. It's all mapped out, so you can 3D model it. And most people just use a Newtonian model to demonstrate it, because it's much easier.
Why do you think that the satellites would have to continuously accelerate and decelerate or whatever? Like, why do you think that?
Because if an object is moving this way and something's rotating around it, it has to then catch up to it at certain times, catch up to what it's orbiting at certain times, and then pass back around it. And to keep a consistent distance, which we're told that it does on its ecliptic plane around the Earth, it would have to accelerate and decelerate to keep that. It's just the motion required. It's just, I don't know, but that's what the model says, so it should be doing that, but there's no indication that it does that.
All right. Well, let's move on to the next question here, because like I said, we're going to spur all kinds of discussion. And LJ strikes again for $4.99. Keep those Q&A super chats coming in, everybody. We super appreciate them. That's the real code for super chat. We super appreciate you. And LJ says, Globy's intro summarized. Trust me, bro. Do ships disappear over the hump when they sail away? How high do I need to go to see a hump in the horizon?
That depends.
Yeah, it depends on the circumstances. Like we went through
on atmospheric conditions mostly. Yeah. But on the average, you can make a pretty good approximation by just ignoring the atmospheric conditions. And in that case, it's a fairly straightforward geometry problem. You've got a circle and then a line and a tangent line, and then
Also, I don't know what he
Check.
means when he says a hump in the horizon. I really don't understand what that's supposed to mean, but I don't think either model has a hump in the horizon.
All right, well, let's continue on to the next super chat, which is also from LJ. LJ, we appreciate you so much contributing to the super chats there and asking so many questions, because you're going to, like I say, spur on so much discussion. So another good old impression for you. Pyramids and cathedrals were built before gravity was made. Now, that is Kermit, not my Jordan Peterson.
There was still gravity back during the ancient Egyptians. Sorry.
Does he think things didn't fall down?
I think he's implying that before we had Newton's equation of gravity, that gravity didn't exist or something, or that they somehow needed to understand Newton's equations in order to build the pyramids, but they didn't. So,
yeah.
All right, we'll keep the super chats coming in, everybody. We'll have all kinds of thoughts to unfold here. And maybe
Can I share one little thing on that, I guess?
I was just about to say, let's see if we have any thoughts on the other side. Go ahead, Mike.
Let me see if I can share a screen.
Absolutely.
Sorry, guys.
I have no problem with that. We're ready for you when you are.
Here we go. So just when it comes to gravity, there's a lot of debate on it. My argument when it comes to gravity is that there's no object in existence that can't be described without using density or buoyancy, unless it comes to harmonic levitation or electromagnetism. But outside of those more powerful forces, I would say that every object that we see could basically be described with density and buoyancy. But Nikola Tesla was a pretty smart guy. He was a contemporary of Albert Einstein. And here's what he had to say about relativity, which is the very foundation of modern gravity. He said that Einstein's relativity work is a magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. The theory is like a beggar clothed in purple, whom ignorant people take for a king. Its exponents are brilliant men, but they are metaphysicists rather than scientists. So even in Tesla's time, this theory, or in Einstein's time, there were brilliant minds questioning it then as well. And when you take into account that the Earth doesn't have the necessary rate of drop that should exist, then that throws off all the math for the rest of the model, honestly.
So if I can just really quickly, Tesla believed in a lot of really weird stuff, right? In death rays, in like free energy, like he believed in a lot of weird stuff. Okay,
he fell in love with a pigeon.
And Isaac Newton believed in alchemy. Okay, just because these guys were right about some things doesn't mean that I have to say that they're right about everything. And to say it's like kind of like an appeal to authority. Oh, Tesla said it, therefore it must be true.
And if we're gonna do it, Tesla totally thought the Earth was round.
Yeah. And then oh man, I had a point. If I remember it, sorry, I'll come back to it. I forgot what I was going to mention about gravity.
Oh, that's a shame that you forgot your thought there. Anybody else have any thoughts before we move on? All right, let's move on from there, everybody. Keep those super chats coming in. We super appreciate them. Let's see. We have the next one coming in here.
Oh, wait. Can I jump in on it? I remembered what I was going to say.
Go for it.
Okay, Mike, you were saying that density and buoyancy can account for this, but okay, if you have like a vacuum chamber, right, and you have an object in the middle of it, and so in every single direction, it's going to be the same density, right? Up, down, right, left, it's the same density all surrounding that object. So why is it that the object goes down? Why is there that specific direction of movement down when the density is equal in all directions?
Yeah, that's what goes back to the not the electromagnetic spectrum, but it has to do with the magnetic draw of the Earth. There's a negative charge on the surface of the Earth. There's a positive charge in the sky. And we know that all matter has either a negative, a positive, or a neutral charge to it. So that would indicate its direction. It's the same way. Okay, so let me give you a real life experiment. Let me give you a real life experiment.
But I don't need you to do that. I can respond to what you said. I understand what you're saying. But if we did that same thing in a Faraday cage, or like what like Tapiocaweasel was talking about, where you cancel out the electrical effects, if you ground the whole system, so the whole thing is grounded, there's no difference in the electric field up, down, right, or left, it's still going to go down. And if you're saying like if gravity, the downward acceleration, is due to electrostatic effects, then
well, is there pressure?
You should be able to nullify gravity in a Faraday cage.
Is there barometric pressure in a Faraday cage?
No,
not if you
in a
pump it
vacuum.
out.
It's equal in all directions. We're saying
we need a vacuum and a Faraday cage. And has this been done?
Yes.
Well, yeah, both.
Yes.
A Faraday cage with a vacuum.
Yeah, that's what.
Well, no, I'm not saying it hasn't been
detailer.
done. I'm always investigating. I'm learning more. Like that's.
I went into
but your
excruciating
explanation.
detail
Wait,
earlier.
let Dr. Tapioca explain, because this is the exact scenario that he outlined earlier.
I went into excruciating detail of exactly how you would measure this. You would do it with a falling object, a corner cube that always reflects things back right at where they're going from, and you can count in individual light wavelengths how fast it is moving. And you do this after you pump out all the air, because air friction is the bane of my existence. Okay? Because, you know, it's annoying and it makes all the calculations harder. So just pump out all the stuff.
All right. Well, I mean, that's something that I'm more than willing to look at. I just don't see how that would indicate that the only conclusion to that is space-time bending around an object of mass, which is what gravity is.
Well, it means that density.
You don't come to
buoyancy
because I've heard that things that block out electricity still at the lowest level still have a detectable. That's what I've heard, is that
I can
it's
address
almost non-existent. It's almost incalculable, but it's there.
So
we're going to let
Grayson
Grayson wrap this one up. All right, over to you, Grayson. We'll let you wrap this up.
I would just like to address those points, because yes, even if there's just a minuscule amount in a Faraday cage, or when you've grounded it or whatever, just like by just random dispersion forces of the electrons, whatever, the thing is that you would still expect for the weight of that object to change. If you've drastically reduced all the electromagnetic fields acting on an object, and you're saying it's those electromagnetic fields that are causing the downward acceleration, and you've drastically reduced it to a minimum, maybe it's not zero, maybe it's just super close to zero, you would still expect the weight of that object or the acceleration to change in accordance with the change in the electromagnetic field, which is not observed. So, like, just because you're saying, oh, this doesn't mean that it's warped space-time, it does mean that you can't explain it with density, buoyancy, or electromagnetic fields.
All right.
Okay, well, I'm not exactly sure
15
why
seconds,
you
Mike.
expect, like, the expectation that you have exactly. I just know that buoyancy and density can be demonstrated, electromagnetism can be demonstrated, and the one major proof that we have for gravity is this cage that may or may not eliminate all electromagnetism or anything to it.
No.
Well, I mean, whatever. I'm just trying to repeat back what you were explaining to me. So,
did I ever say that was the one proof of gravity?
So can you give me an example outside of the Faraday cage that you think exclusively demonstrates gravity and its effects?
The Cavendish experiment.
Also, we already talked about this.
Static.
You're on mute, Flatterday. Flatterday, you're trying to speak and we can't hear you. Just let's let Flatterday in here.
Okay.
There you go. You're off mute there. I don't know how you got on the mute, but Flatterday, you're back in.
The Cavendish.
I was just wondering if a helium balloon or a hot air balloon would demonstrate gravity, or the lack thereof.
Yeah, if you have a helium balloon in a vacuum chamber, it's going to fall at the downward acceleration of gravity.
Because there's no medium.
Because basically, life on Earth is like being in a vacuum chamber. So that's something that's observable, testable, and repeatable in the natural world.
It's not gravity. It's that it has to disperse. The helium has to fill the pockets of the vacuum. It falls because it disperses. It doesn't fall because space-time is forcing it downward.
That's not why it falls.
Well, okay.
It's not leaking helium. Like, out of the balloon, whatever. You can make a strong balloon.
You said if a
How would
helium
you-
balloon is in a vacuum, right? It's gonna
It'll
fall. You're saying?
fall at 9.8 meters per second, or very close.
Oh, okay.
Bro, how would you keep all
I
that?
was
How would
sorry.
you
I
keep
was thinking of a hot air balloon. For some reason, I was thinking open, uncontained. I got mixed up with the, yeah. Never mind.
Last word
well,
to
the vacuum you're
Flatterday.
talking about? It's completely contained. Like there's no air, right? It's completely airproof. Like just
Are you
solid
just
container,
saying
right?
that pressure needs a container? Is that where you're going to?
Well, there's just no medium
Is that what you're
around the
saying?
balloon.
No.
So what
Is that
would
what
it
you're
rise
saying?
off of?
Gravity can contain pressure without a container, and electrostatics can do it too. There's lots of
But
things
the
that
experiments
can
you're talking
contain
about,
pressure.
everything is contained, though, right?
Look at a water
But what-
droplet, right?
but what I'm
Why does
saying-
a water droplet disperse? Because there's a force holding it together. It's the same thing. Like a force is capable of holding pressure together without a
Yeah.
container.
And in
And
your
a
model,
drop of water can show that.
And in your model, it would be ascribed to gravity, correct?
Yes.
But there are explanations outside of that model that can also explain downward force. You just don't, you laugh at those answers, and that's fine. I can say that the helium balloon drops in the vacuum chamber because it has no medium to rise against. That's a simple, easy to understand explanation that
All right.
makes
We gotta
perfect
move on.
sense.
Quickly, can I wrap this one up? Can I wrap this one up before we go? Because I just want to say, it's
15
not just
seconds
that we're-
because we do need to get to the
I
next
will. I'll wrap
super
it up.
chat.
I'll wrap it up. I just
15
want to say,
seconds.
it's not just that we're laughing at the things that you're saying. We are demonstrating why they are not true with things that Tapiocaweasel has done in his lab. So we're actually using. We're
5
not just
seconds.
laughing at it and smirking it off. We're just explaining why empirically it's not true and why buoyancy density and electron magnetism cannot explain it. It can't help you here. So,
All right.
anyways,
Let's try to move on to the next question, guys. We'll have all kinds of time, I think, to respond to these questions because they keep pouring in. And as you guys are answering, 1, 2, or 3 are pouring in. We super appreciate it here at Modern Day Debate. And I hope you don't feel like we rushed through any of your super chats. There's going to be lots of juicy discussion. So as long as everybody's good to stay and have this discussion, I want to let all of our speakers know there's no pressure. If at any time you're like, hey, you know, we've been going for so long, I gotta duck out, that's totally cool. But if you're here to fight the good fight, and that's what we're all about here at Modern Day Debate, we'll keep on rolling. Congo 44, $10. Question for the flat earth people. So if the sun can be brought back by zooming in, can you turn night into day by zooming in? Ding. Also use a solar filter.
No, every lens has limitation, and there's angular resolution, so things have a vanishing point. Even our most powerful lenses, and also when you're looking horizontally, again, there's such thing as atmosphere, so that exists. And the further you look through atmosphere, the more obstruction you have. So,
Atmosphere does not exist. It's fake. Just saying.
All right. That was for the Flat Earth side. So, Flat Earth Saints, let's close us out on that one. Question to Flat Earth people. So, if the sun can be brought back with zooming in, can you turn night into day by zooming in? Ding. Also use a solar flare or a solar filter. Sorry.
Well, I've heard them say that the stars that we see in the sky aren't even there. They've exploded a long time ago. So theoretically, I guess in the heliocentric model, sure.
Well, if you're, I mean, he's kind of invoking you guys a little bit there. So if you want to give them a chance to respond, Flat Earth Saints, or do you want to move on to the next question?
Either or.
All right. Do you guys have any response there?
I had a point that I actually wanted to make earlier that I had forgotten about until just now. The argument that Polaris has not moved in the sky, that is demonstrably false. The first time Polaris was called the pole star was in the 1500s. I have located, and I have a conversation with Pitch Lumen with Nathan on this topic on his channel, and I showed exactly where it says that the first time it was called the pole star that we know of, it was 3 degrees away from the actual pole, which is significantly more than it is now. And just last year, there was a study published where they had found a record from Hipparchus about the position of Polaris, and it was 12 degrees away from the North Pole.
Bro, they also say that the climate's changing all the time and they're trying to stop climate change. Well, the truth is the climate's changing every minute from hot to cold. So
Wow,
and it is true
bro.
they're trying to stop climate change because if they do stop it, it'll kill us. The climate has to change every day, every
Oh wow,
minute, every hour.
it's cold in winter, therefore climate change is not real. That's what you sound like, man.
That's what you said. Climate change is very real. It changes every minute of every day. Fluctuates hot to cold, hot to cold.
I don't think you know what climate is, bro.
Just you can't bite
you
on
realize
every,
that
on
I got something to say on the North Star thing.
Sure thing.
The thing with the North Star that was really eye-opening to me, again, that I found very problematic when it comes to the heliocentric model, is that I couldn't find a single model that took and 3D modeled the North Star using the actual heliocentric model. If you look at every 3D model that you can find for the North Star, whether it's on YouTube or Google searching it, they're all going to give you the exact same demonstration, the identical demonstration, which is based around a stationary sun. But if we look at this right here, this is essentially how much motion the modern heliocentric model should be experiencing. This is essentially what should be occurring if this model is true. But if the North Star were allegedly following the tip and the northern point of our Earth in this model, it would be impossible to model. That's why they never do. They only use a Newtonian model. So go investigate for yourself, anyone who's watching. See if you can find a single 3D model that takes into account the motion of the sun while it tracks the North Star. You won't find one.
Do you know how far away the North Star is to where, like, do you know the actual what the difference?
We probably know this. Let me find out.
Yeah, it's
the closest Cepheid variable star. So we actually really do know exactly how far away it is. The Polaris, I believe, is the closest Cepheid variable star, that's remarkable.
Well, I'm just saying,
therefore God exists.
You could calculate how much you might expect it to change due to the movement of the sun. I mean, that is a stellar parallax. You could calculate that value. It'd be very small.
In a Newtonian system, yes. Leaving out the motion of the sun entirely and the Earth's following of the sun.
You could calculate it with that in mind.
No, you can't. Or they might give you a number that they say, and this is the number, but if you try to 3D model it and make it work, the North Star wouldn't be in that position. It can't be with that amount of motion. Otherwise, there'd be a 3D model showing it, and they don't do that. It doesn't take it into account.
I think that you're just making claims that you can't substantiate at this point.
Okay, well, that's fine.
No, he's just discrediting your claim. He's not making any positive claim.
He just said that there's no 3D model that is capable of modeling.
He's not making a positive claim. He's making a negative claim.
That is a positive claim, dude.
That is a positive claim.
Wow.
That's a positive claim.
Okay.
Well, let's move on to the next question, guys. Like I said, we got all kinds of discussion to have here. Hit that like button. This has been a really juicy discussion, and I'm really glad that we were able to get this discussion happening. A big round of applause, virtual applause, for the speakers here tonight coming out to have the discussion. Yeah, we welcome everybody here at Modern Day Debate. Let's ask the next question. LJ for $1.99. YouTube, in quotation marks, day and night at the same time. Countless vids.
There's countless videos of day and night occurring at the same time, or what?
The rest of LJ's questions has been, towards your side, so I imagine it's for you guys.
Okay, well, it's nighttime somewhere right now in the world, and it's also daytime somewhere right now in the world. So, yeah, I don't understand what his point is at all.
I've been up high in a plane, and you can see that over there it's nighttime, and over there it's daytime. And I guess in that sense, there's daytime and nighttime on the same side, but like that's also like what dusk is. So, like,
I think maybe he's misunderstanding.
This is also this isn't something that is like this would be just as confusing in both models, in my opinion.
I don't think it's that confusing in the globe model because
I agree, but
the Earth is
think it
obstructing the view of the sun on the area where it's nighttime on Earth. The Earth is physically getting in the way of the sunlight. But that's not occurring in the flat Earth model. So what is getting in the way of that sunlight in a flat Earth model? So I don't think it's hard for our model to explain at all.
Actually, that's
right. You're invoking a flat Earth model that neither of us invokes, bro.
That's the perfect tool, and I actually agree with your point, Grayson, because I do not. Unfortunately, I can't pull it up at command, but I do. Well, okay, then I'm a liar. Whatever, I'm lying. But I will say that I do have footage of high altitude footage where you can see the sunlit side, just like you're describing from the plane. You can see the sun on one side. You can see the nighttime sky and the moon, and you can see both bodies are above the surface of the Earth. So it's not the edge of the Earth blocking the sunlight out. It's still visible because in an average airline, you can see about 200 miles to the horizon. So you can see a pretty good distance at that point.
Again, the presence of the moon does not signify nighttime.
Well, no, I'm not saying that the presence of the moon, but I'm saying if the edge of the Earth rotating away from the sun is what's blocking the sun, and you can clearly see above that horizon that the edge of the Earth is not blocking the sun because you can see where the terminating line of the sun is, then you're showing that it's not the bulge of the Earth. It's literally that the sun has a limited range, like all light does. It has a limited range. It can't just project forever.
So are you talking about tired light here? Because that's very easy to debunk.
All right.
I mean, light can keep traveling for millions of light years. I mean, there's nothing that limits the range of light. It doesn't get tired as it travels and lose energy. And
it just disappears,
But the model says that the globe model Earth rotating away from the sun, and the unlit side that's facing away from the sun is why there's dark. But you can be in a plane high enough to where the sun should be hidden behind that curvature, but you can still see the nighttime portion of the Earth from a high enough altitude.
I know you want to respond, Grayson, but we do need to move on.
Want to respond just really quickly. You can still
10
see
seconds,
the
buddy.
nighttime
We
part,
gotta move on.
but you're not there. You're in an airplane. That's why you can see it from a distance, but it's not nighttime for you because you can still see the sun. You're not.
But there should be curvature too. There should be a big arch one way.
We're going to move on to the next question because, like I said, they're pouring in faster than we can answer them, and we'll be here all night if we keep getting to the back and forth. And we really do appreciate it, and I'm sure that everything that you guys are thinking right now will get fleshed out before we finish because people are going to ask those questions, and they're going to want you guys to get those thoughts out on the table. So Sunflower, member for 25 months, thank you so much for that, says, why doesn't gravity work on the quantum scale?
Because it's so weak that the effects of gravity are only really demonstrable for very large masses at very large scales. So it's such a weak force in comparison to the other forces that once you get down on the quantum scale, the effects are so small that we don't have proper measuring equipment to even measure them.
Yeah, we can't measure it. That doesn't mean it's not there.
So it's just theoretical, like Santa Claus kind of at that point.
Well, yeah, quantum gravity is even probably less than theoretical because we don't really have a theory describing quantum gravity right now.
We have competing models.
I should say we don't have a
complicated thing. We're debating whether the Earth is flat. It's like
competing model. That sounds like a
you got to crawl before you can run.
I should say we don't have a consensus theory for quantum gravity.
Yeah. Yes, that's true.
All right, let's move on to the
flat Earth Army. Shirts in the back, snacks on the way.
Thanks for that flatter day. Let's move on to the next question there. LJ for $1.99 says, the doctor, we'll leave this one just to you. I'm going to set a 1-minute timer without interruption. LJ says, the doctor can't comprehend his life has been a lie. Have you heard something like this before, Tapiocaweasel? 1 minute and the floor is all yours.
Yeah, I suppose I have, and I don't I don't have an answer that this person is going to find remotely satisfying, other than to say you don't comprehend like how many things preclude the possibility of that from so many different directions. But I'll give you the point you're going for. If the earth is flat, then that would totally totally mess with me, and I would probably be in a state of horrific cognitive dissonance. So there's the quote and the acknowledgement that you want.
All right. Well, thank you so much for answering that question. We're going to move on to the next one, which is from Congo 44. $5. Question to Flatter Day. Just for you, Flatter Day. 1 minute for you. Do you enjoy... Well, this. All right, I'm going to try to clean this up because it's just kind of ad hominem, Congo. I'm sorry.
I like it dirty, bro. You can make it dirty.
Well, they are saying that you are ignorant. So they're saying, do you enjoy wallowing in your ignorance? It's pretty gross. So they're accusing you of being ignorant. A 1 minute for you to respond to Congo, as juicy as you'd like.
So ignorant on compared to who? Compared to what you consider smart, or compared to what are you considering ignorant?
All right. Well, that one we will move on from. LJ, because strikes again. LJ, hey, thanks again. $4.99. Spinning space ball without curve, water. Explain why you still blindly believe in the fake core model when the deepest hole ever dug was less than 8 miles.
Because of seismology.
Any thoughts over there, Tapioca, or do we want to move on?
Because of seismology.
All right. OC for $2. No question attached to your question, OC, or your super chat, but we appreciate the $2. LJ says, Ryan has been a great moderator. Well, thank you.
Claps for Ryan.
Yay. I always like a little bit of
You've been a
joy
model
for them.
moderator.
Oh, me, yes. No, I was going to say, I probably should work out more, honestly, more than just my vocal cords, which, yes, to the people who are asking at the beginning, that is me singing, and I do play the guitar solos. And from what I know, your old pal Mike is no slouch when it comes to playing music as well. So, you know, you can always check out that as, us as musicians. That's cool, too, because we don't mind screaming in the microphone. That's cool. But not here at Modern Day Debate because we are gentlemen. Cool Biko, $5. Flats have no passion for the subject. They know they are wrong. They're coming right at you guys. What do you think?
If being wrong is a helio, then I don't want to be right.
Well, good, you aren't.
Any thoughts there, Mike?
I just look at everything like I'm still examining. There's pieces to the puzzle that I can't personally test. So, like when it comes to Antarctica, we all know there's a treaty that doesn't allow independent exploration or travel beyond the 60th south parallel, and we know that there's a treaty around the North Pole as well. So, and even our airspace is governed. So, all of it is kind of still subject to learning. I feel like there's too many pieces of the puzzle to come to a full conclusion, but I do know that there's enough modern technology and enough experiments out there testing the surface of the Earth that there's no reason to believe it's a spheroid of 24,901 miles in circumference.
Can I make a really quick point about the Antarctica stuff? So
couple seconds there, but I'm not sure how long that might take.
This guy on Twitter, Mike Buckner, he's a flat earther. He actually, I give him credit. He wanted to put his money where his mouth is. He decided that he was going to go to Antarctica himself and expose the fake globe Earth, expose the ice wall. And he said that he would
Way
be
to open a can of
all-
worms, Grayson. We
He'd be
are
streaming
going
it-
to talk about this for a little bit. I'm pretty sure.
I just want to make the point. He said
we didn't touch on it yet. You know that this
he
is
had
happening.
the tickets. He had it all set up. He said he was going to be streaming it live in 24 hours, and then he never tweeted again. He hasn't tweeted in 2 weeks. He said he was going to expose it all. He went to Antarctica himself. He's too embarrassed to put it out there. Also,
the man got to him.
Yeah, the deep state got to him. Also, North Korea is not in the Antarctic Treaty, to my knowledge. Why doesn't North Korea expose this? They have an interest. They're against the West. If they wanted to expose the West as liars, surely North Korea, who has a nuclear energy program, they have nuclear bombs. They're not dumb. They have scientists.
Now,
if they
somebody...
could prove it, they would. It would be in their own best interest for the North Korean government to expose the lies of the West and show that the Earth is really flat, if they could.
Well,
like you as a civilian would know the best interest of North Korea. Come on, bro. Fantasy.
They're anti-West. Don't you think it would behoove them to expose the West?
Here's what I would say on that. There are 55 nations that currently uphold that treaty. What would benefit North Korea to poke the bear and break that treaty? They're not allowed there. Why would they break that treaty? And the other point I would make is that it's not mythology to know that Antarctica has the highest elevation of any continent on Earth. So if it was the outside rim and it was holding the oceans in, it does fill that. And if anyone thinks, oh, the Antarctic ice wall is a joke, jump on Google right now, type in Antarctic ice wall, look in the images, and you'll see that there's big, giant walls of ice. Like, it's not a gag. It's the highest elevation on Earth. It's entirely made of ice, and it seems to hold in the oceans. But, I mean, even on the ball, it's the tip of the oceans, you know? And here's the thing. Most people don't realize that the flat model and the globe model match really, really well in the northern hemisphere. It's not till you go further and further south that they diverge. And interestingly enough, there's a treaty at the 60th south parallel when the greatest divergence begins. So I don't know, make of that what you will, I guess.
Just buy a flight from Santiago to Sydney and tell me how long it takes, and you'll know if the Earth is flat or not.
Why, though?
Because
Because
on a flat Earth, you said it yourself, that the divergence in the southern hemisphere becomes greater and greater. So if you flew from Santiago, Chile to Sydney, Australia, and you compared the time that it takes you to do that flight, you could do this flight yourself. You will see that that is not significantly different from like New York to Dubai. It's about the same time. But in a flat Earth model, those are way different distances. And if you say, oh, it's just the trade winds.
All right, let's let Flatter Dave
anywhere. Yeah. Couldn't you fly in a plane anywhere and notice if the pilot doesn't continually dip the nose of the plane down to adjust for the curvature of the Earth?
No, you wouldn't notice that.
You wouldn't notice that, really?
No, you would not. Correct.
Why would you notice that? It's going to be way smaller than the fluctations from the wind.
Coriolis effect for shooting, right?
Wait. Quick question.
Coriolis effect for shooting, but not for an airplane. Okay.
You're not constantly manipulating and adjusting the course of a bullet. If you were, then all of that shooting business would be a lot easier.
Okay, well,
so you're saying that airplane pilots don't adjust the nose of the plane to make up for the curvature of the Earth?
Look, what we already said, what both of us already said, is that just the normal turbulence is going to cause higher amounts of course correction for the pilot than this effect would. Just do the calculations yourself.
If the pilots don't touch the controls on an airliner with the way that modern airliners are structured and the way that they're weighted and the way that they use the rear things to sort of counterbalance, they are aerodynamically going to self-stabilize in a level flight, which is going to self-adjust to the microscopic amount of change in which direction is down as it goes.
So the plane has an adjusterometer.
Wait. Hold on. I got to address this.
An adjusterometer?
All right, let's let Mike in here, everybody.
Hold on. Microscopic amount of adjustment. A plane flies at 500 miles per hour. Do you know how much drop should exist in just 200 miles?
You understand that lines of isobaric
26,000 feet
Yeah.
in just 200 miles.
Okay.
So before course, hold on. So before course correcting planes, those dudes must have been white knuckling those steering wheels to keep around a curve. 26,000 feet in just 200 miles.
Right. We got to let Tapiocaweasel respond here.
They do it continuously. You have to express the amount of correction in terms of arc minutes or something per second. That is the appropriate way to do it. And if you look at how fast planes move around, just from very, very normal, completely unremarkable winds that don't even rise to the level of mild turbulence, you're going to find that this is well within just the noise of how a plane moves. It's not fast. It's not orbiting the Earth. If it was, it would burn up.
Do the math yourself, Mike.
It's the rate of drop that should exist. That's really rapid, because it's only flying at about 35,000 feet. And just in 200 miles, let's see, 500 miles per hour, how much drop should that drop right there in 500 miles? You should lose 100.
You can't. That's not how you do the math.
Feet.
No. You can't do that. You can't apply. You can't look at how far a quadratic equation, which is what the sphere could be approximated as in this thing, and then divide that as a linear distance. You have to account for the fact that it's a continuous thing. So you can divide this down. If you're going at a mile per second, for example, a mile per second is like a reasonable ballpark airplane speed. Okay, then that is 8 inches per mile. That means that the thing has to go down by 8 inches over a fucking mile.
Every second.
Exactly. That's microscopic, dude. Do you know what 8 inches in a mile is? Do you know what that angle looks like? It looks like much smaller than the fluctuation of the plane.
Microscopic. It's observable to the naked eye.
That's the first mile.
Oh my god!
It exponentially grows.
It's continuous. But
the calculation isn't 8 inches per mile. The calculation is 8 inches per mile squared. So the greater distance you're traveling, it grows exponentially. It's not like 8 inches, then 16 inches, then 20.
My piece.
Okay, look, Mike, if you are continuously adjusting, then all that matters is like the per second. It's the derivative. So you're saying after 1 hour they should have
built into the plane.
So you're saying after 1 hour they should have all this drop to account for, but it's not like they're accounting for it every hour. They're continuously adjusting.
They would be doing it as they go. And what I'm saying is older planes were not outfitted with that technology. And I've heard pilots break down how they never accounted for that amount of curvature. So
you need an altimeter.
What?
You just need an altimeter to measure your altitude and stay on the same altitude line.
Exactly.
Okay, so how do they stay on it? How do they constantly adjust? Is it built into the plane or do the pilots do it?
On the globe, they'd have to go and wrap around that curvature. There'd be curvature. They have to go with
that is what they're doing. As we have been pointing out, the adjustment needed to stay on that curvature is smaller than the adjustment needed to just focus and just keep going without the turbulence. Like the normal wind pressures and turbulence that it's experiencing are a much greater factor than the amount of adjustment that they need to make for curve. So they're paying attention to just keeping the plane straight at this steady altitude. That's what they're adjusting for. And that automatically adjusts. That automatically adjusts. That accounts for the Earth's curve when they're doing that.
You think a plane in 5 miles in 5 seconds is dropping down 16 feet? In 5 seconds? It's dipping down 16 feet.
15 seconds and we're moving on.
Again, you need to measure this in arc minutes. You're measuring this in altitude relative to the start because you're assuming a flat Earth.
In reality, bro.
Go. Huh?
Yeah, reality minutes.
That doesn't make any sense. But thank you for contributing.
The claim is that gravity is holding the
5 seconds, buddy,
at a certain distance and keeping it level around the surface, correct?
No, absolutely not the claim.
No, so it's not level around the surface of the globe model Earth. It loses level.
It's not gravity that's keeping the plane at the same height, man.
We're trying to move on, everybody.
So much more stupid to get to. But okay, no matter what position we all hold, you think that we're
going to prove your point, bro? That's going to prove your
You
point.
think that
Way to
we're
go.
stupid.
You got a
You think that
PhD?
we're stupid.
Go
My
ahead with
point
your
is,
PhD.
no
I
matter
think you
which,
guys are smart.
I never said you were stupid.
well, you think
You
the
said that
opinions are
about us,
stupid
bro.
then.
All right, let's try to
I
move
never
on to
said
the
the word
next super
stupid, you
chat.
did.
We're gonna let's
But
let's
that shows you have a
hold on.
PhD.
Well, let's just all just we're gonna take it down for just 1 second, everybody. We're gonna move on to our next super chat. We're gonna use our proximity effect to calm everybody down because we have lots of super chats to go, lots of great discussion to happen, and I want to make sure that that comes through cogently. So let's move on. Sunflower for $5 says, most people with PhDs show restraint and tact. This tapioca guy is bursting at the seams with soy rage. He's coming right at you right after I said, let's calm down, everybody. All right.
Yeah.
He probably hasn't worked in the private sector, says Sunflower.
It depends on what you mean, I suppose. My university is a private university, so I guess in that sense I do work in the private sector, but I do work in academia. And also, you know what, you're right. You're right, Flatterday. I and Mike, when I said that, I realized as it was coming out that I was calling you stupid, and I didn't mean to do that. I meant to what I was trying to do, and what I tried to follow up with, and I should have led with this if I was going to make this point, was I was trying to say that regardless of our position, we think that the other person's position is absurd for numerous reasons, and in that sense is stupid. So I wanted to address what I just said, because as the question asker just asked, I'm a beta cuck soy boy, is I believe the term.
If I may, just really quick, for those of you who don't know Sunflower, okay, Sunflower, the guy who was saying this about my debate partner tonight, Sunflower's been on my streams. We've had debates back and forth, and I just want to say, like, Sunflower's voice is at least an octave higher than Tapioca's voice. He's like, "Oh, Grayson, you're so wrong about everything."
Oh,
so
man.
just pay attention to who that comment was coming from. Not exactly a peak specimen.
Hold on. As somebody who sings a lot of Judas Priest, I won't allow you to make fun of people with high-pitched voices. Moving on to our next super chat. Cool Biko for $5. Sorry, we already read that one. Jack Nelson for $10. Bad Science Sundays. Dr. Tapiocaweasel is the man. Let's take our shirts off and dance like we did before.
I don't think, did I take my shirt off?
All right, maybe not. No. We don't want to get demonetized. That's fine.
I've
done worse things at rock shows, honestly, but I don't think we should take our shirts off. But we have a fan, Jake Nelson. Thank you for your super chat. I
just want to say what he's referencing is I host a show called Bad Science Sunday over on Maya Adkisson's channel. And Sunday evening, you should come check us out. We've been doing it for, I think this will be episode like 31 or something.
Excellent.
Episode 33.
33. All right. There we go. See, I'm terrible at counting, I guess.
Excellent. Well, look at that. We have two
was
fans.
a Masonic, right? No. No.
That's good.
Well, I'm glad everybody's having fun. If you're having fun in the live chat, if we're having fun in the debate, hit that like button, because honestly, at the end of the day, I think everybody could get along and we could all play video games together. Or music together.
Sure.
That's for sure.
I don't play video games, homie.
All right. Well,
I don't have any content. I just want to cut in. I don't have any content on my channel. But I know that Grayson does have content on his channel. I don't know if Mike and Flatterday have a lot, because I just met you tonight. But I do notice that currently in the description, I don't see links personally, but maybe that's just me.
I have about 400 videos on my YouTube channel.
Okay, well,
maybe not
about
yet, but
20-something.
we will get them updated, and we will make sure that they are tagged in the
I can send it to
podcast.
Ryan.
And I will make sure,
Thank you.
just because I referenced my fellow, musical player here. This is Mike. this is his second time on Modern Day Debate. He runs the Flat Earth Archive on Facebook. He's a super cool guy. He plays punk music. He's a good singer. Go check him out if you like what you're hearing. Go check out all our speakers. I just wanted to put them up on the screen and big there for a second so that everybody could see, yourself there, because we had a chance with everybody, I think, with the screen share, except for yourself, Latter-day Saints. So I'm going to give you 1 second because as far as I know, you're the only person that hasn't done a screen share or a pitch for where you're at. So Latter-day Saints, where can everybody find you?
Latter-day Saints at YouTube. That's the name of our YouTube channel, Latter-day Saints.
All right. That would be the pitches there.
I'm a flat earth rapper.
Ooh.
Oh, I think I've seen something of yours before.
Does anybody else play music here? My goodness. Who else here plays music?
I have no discernible musical ability.
That's totally fine. No, I was going to say, we don't judge based on musical ability. We just like having great discussions here at Modern Day Debate. And I hope you enjoy my music at the end of all this stuff. My buddy Josh was here last time for, some of the fun, who is my band compadre. And we're trying to work on some new stuff and get some real drums on the Modern Day Debate track. So stay tuned for that. Let's continue on. LJ, oh, wait, sorry, I got to scroll up a little bit. I'll scroll up a little.
I may have to duck out in about 15 minutes here.
Well, we'll try to keep it down
bro,
to.
I can handle both these dudes, bro.
I think it's been, honestly, I feel like it's been a fun discussion. Everything gets, a little heated, but in a good way, like a respectful way, I thought. So, I mean, whatever, we're all just figuring stuff out, whatever.
Yeah, I gotta say, Mike, on a personal level, I like you, man.
I like you guys too. You guys are fun.
Both of you have comported yourself. Yes, very well.
I like everybody here, honestly. You guys are all awesome. As soon as we get everybody linked in there, I hope you go check out their links in the description. You give them a like and keep an eye on these fellas because I'm sure they're going to be back for lots of juicy debates. I'm going to set a 2-minute timer for each of these questions so that we can run through them. And that way, if we get any more for Mike, he is here to address them for you if you have something for Mike. So Congo 44 for $5. Question. Oh, hold on. They're moving around. Sorry. That's not. We've already asked that one. See, that's the play. That's the pain of all this. LJ for $4.99. Spinning ball. Spinning space ball with curved water. Oh no, we've asked that one as well. My goodness. See, this is the problem when so many people have asked so many questions, and then I try to rush through because I'm like, No, I have to bring it back down, everybody. We all take a deep breath.
We covered a lot,
That is true. We've covered a lot. All right, so haters
covered a lot of curved ground.
Hates stairs for $5. Dr. T, please come back to Modern Day Debate. Great arguments and presentation. Well, you got a fan out there. That's really appreciated. We love these super chats. That is from
the person?
Hates stairs. Everybody hates stairs. Do you hate stairs? Do you wish everything? I like
escalators better.
Yeah, everything.
It's the only exercise I ever get. So yeah, but it's I hate my brother too.
I live upstairs. You hate your brother? What the?
I have two brothers.
What does that have to do with stairs? Do you throw them downstairs? What's going on? All right, we'll continue.
It's complicated. Thing, right? Okay, that's my relationship to stairs is like my relationship to my brother. It's complicated, but on the whole, I depend on them.
Okay. Cool Biko for $5. Thanks, Cool Biko. Being animated in the debate doesn't mean you're being emotional. Thoughts?
I don't have emotions. Who would say that I was emotional?
Nobody would. They'd be so upset with them if they did. All right. Let's move on from there, everybody. We can all have fun with that, I'm sure. But we have only limited time here with Mike, and we want to get through these questions. So LJ says for $1.99, having a doctor title only guarantees I was a nerd.
Well, yeah, Yeah, I mean, I can't really disagree with that. I suppose, like, if you're a physician, you like surgeons aren't what most people would call nerds. There's a certain personality, but on the whole, 99% of the time, yeah, if you're a doctor, you're a nerd.
Yeah, I can vouch for that because I applied for multiple PhD programs and they all told me I was just too cool. So
Boom.
Oh, my problem too. My
He
goodness.
needs to exit right there. Just the mic drop too.
Moving on to Jake Nelson for $10. This is so frustrating. What was the date and time for his observation of this video? That matters for the placement of the 3 bodies. He's talking to you, Mike, I think, because you shared a
Yeah.
personal
in the
video.
Oh,
Yeah, it's at the if where do I have it saved?
it was 2014, right? Or something?
28, I want to say 2018, but I have it on time
You
and
said in the
date.
beginning of the video.
Yeah, exact. Good memory, dude. Yeah, I pulled up timeanddate.com just to be sure. So it wasn't me just pulling up a website or whatever. It was in real time. So I had 2 phones with me. So I documented in real time my position and the exact percentage of illumination of the moon at that exact moment. So I could try to, I don't remember where I have it saved. It's somewhere, but yeah.
But you can rewind the video, dear viewer,
Yeah.
and you can see it's at the beginning of when he played that video. It said the time and date.
Yeah.
Rewind the telemetry data.
What is
Or
it?
did they lose it?
Oh yeah.
The telemetry data, bro. Rewind it. Play it back. You know what I mean? With no delay on a landline phone. You know what I mean?
Yeah, I've got
238,000
my
miles
tinfoil
away.
hat on, so that blocks all telemetry signals.
Oh, right.
Yeah.
All right, let's move on to the next question, guys, before we get into the tinfoil stuff. We don't want to get too off the base here. So we have LJ slapping another super chat in there. Thank you, buddy, for the super chat. Flatter day absolutely destroyed the globies. And then he puts a little expulsion and then a fire, emoji. So,
Hey, like we always do about this time, homie. It's second nature. You know what I mean?
Yeah, I don't know if he's saying like he can't see you doing something over the fire while a monkey watches and is sad, but that's what I got out of those. Yeah, don't do that. All right, Jake Nelson, $5. Perpendicular is the opposite of parallel.
Yes.
yes.
Because earlier he was saying perpendicular is the opposite of horizontal, but what he meant to say was vertical is perpendicular to horizontal.
It may depend.
Tapioca, don't just say it's approximately okay and nod your head. You don't need to go all the way.
Break it down.
All right.
Parallel means that they never cross, but they're in the same plane.
You guys invoke parallel. I never said parallel.
I know.
Y'all are invoking shit I didn't say.
We're talking about the questioner, man. The questioner did say it, so don't blame us.
And I did accurately say what you had said, and what you probably meant to say. I didn't twist your words on that. So.
You never know what I meant to say, bro. Only I do.
Well, if you meant to say that perpendicular is the opposite of horizontal, then that's a nonsensical statement. So I was giving you the benefit of the doubt that you were trying to say an accurate statement, like vertical is perpendicular to horizontal. So
most of the stuff you've said during this debate's nonsensical, bro. I mean, that's obvious, bro. I hold these truths to be self-evident.
All right.
Let's move on to the next question there, everybody. So the next question was actually Dr. Dino. He had said for $5. And I mentioned it earlier. We're going to have an after show. Everybody who's here on the panel, you're absolutely welcome to join the after show. I'm going to put a link in our chat in just a few minutes. I'm going to message, actually, Dr. Dino, not Dino. See, you got the E there, and that's the Canadian coming out of me. Dr. Dino, send me on Discord your link to the after show, and I'm going to put it in our chat. Thanks, buddy. All right, Jake Nelson for $5. Grayson, antipodes are real. Does back down. What?
I don't think I ever conceded that antipodes are not real. They're clearly real positions on the Earth's surface. So, What I showed was that they actually have a real empirically measurable meaning to them, where you can see that radio waves and seismic waves focus and get stronger at the antipode. So it does have physical significance.
That's something I want to learn more about because I was actually completely unfamiliar with that term before tonight. I hadn't even heard the terminology antipode. So another little side area to learn about. Yeah, cool, man.
Oh, so actually, I am in similar company. I had heard the term antipode, but I've also seen it was on an episode of The West Wing once. But I had not heard antipodal. What was the term? Refocusing, resonance, focusing. I had not heard specifically of that term antipodal focusing, which is basically when if you have an earthquake on one side or a big seismic impulse on one side, that you're going to have diametrically opposite on the other side of the globe.
Oh, okay.
You're going to have an increase in things. So I had also not heard of that term until today when Grayson and I were talking about it. So you learn something new every day.
You played it off like you'd heard it before pretty well, though. I got to give you props on that, bro.
Well, I mean, I have a PhD in being able to convince people that I'm smart, literally.
Of course you do, bro. You follow directions well, bro, and you don't question anything. So you're a very good follower.
I don't think that that's ever a part of the PhD process to not question.
Completely part of it, bro. Even the name university is something false. There's no such thing as a universe, bro.
Sure.
Listen,
We live in a closed system, tell me.
All right.
We're all
1
in the
minute for
dream
this last
of a
point.
giant moose.
A moose that's in Canada. That's right. Moo! That's right. The Canadian moose is striking again to say, let's move it on, fellas, because we got a couple more super chats here coming in. And keep those super chats flying in. And I just messaged, like I said, Dr. Dino to say, where's that link for the after show? And we'll get that into the live chat in just a few moments. But keep those super chats flying. Jake?
I got to duck out, sirs. Felt like it was a good meeting everybody I hadn't met before, and maybe I'll come across some of your materials and stuff, and or maybe we'll chat again or something. But hope you all have a good night, and yeah, it was a good conversation, dudes. So appreciate you, Ryan, bringing me out and thinking of me. So
well, I was gonna say, if you had just one moment there, Mike, before you go, I would be more than willing to give you a minute to give a closing statement if you want to give your closing thoughts on the discussion you had tonight.
All I'll say is what Scripture tells us to do, which is test all things and keep that which is true. So that's all I'll say.
All right. Well, a big round of virtual applause for Mike. Thank you for being here, Mike. Keep rocking out, buddy. Keep playing music. I hope to see more of those links, you know, from the Instagram there. And once again, we'll have everybody linked in our description so you can find out where they are if they're not linked already in our description. So thank you, Mike, for being here, and feel free to drop out whenever you want to there.
Later, dudes.
Don't forget to keep doing your part in flattening the curve every day, bro. Only you can flatten the curve. You know what I mean?
That's right. Later, dudes. We're good.
All right. Thanks, buddy. All right. Well, let's move on from there. All right. Who's got the shoulder there? Oh, that's the shoulder there. I got to fix this up. So we're just going to do that. Isn't that better, everybody? All right. Well, thank you to Flat Earth Day Saints for staying around and representing the Flat Earth side for the rest of our super chats. We super appreciate you being here. Let's continue on with the super chats. I screw up because that will be
AKA Flat Nasty.
Oh, Flat Nasty. Okay.
Oh, wait, is that your rapper name?
AKA Flat Nasty.
Oh, sorry. I didn't mean to do like a parody like that was a thing. I just thought you were saying something.
I'm just saying, though.
Flat Nasty.
Flat Nasty.
All right. Let's keep going with these here.
Is that 2 words or 1 word?
Whatever you want it to be, bro.
Ooh. Well, that reminds me of an old clip. All right. LJ, $1.99. Sun sets like the traffic light 2 miles ahead of you. That's for the globe side.
I got no idea what he's talking about with traffic lights being 2 miles ahead of you and setting. I've never seen a traffic light set. Don't know what he's talking about.
Can you clarify maybe what Jake Nelson might be saying here, Flatter Day Saint?
I mean, I would assume that he's saying, like, if you're 2 miles away and you see a traffic light from 2 miles away, it's going to appear possibly like the sun appears from far away, setting, might turn into like an oval shape, is what I'm assuming he's saying. It's basically straightforward, no pun intended.
Well, yeah, Jake Nelson, though. Jake Nelson is not a flurf. I know that.
I don't know what that means, bro.
Jake Nelson is not somebody who believes that the Earth is flat. So
maybe he just knows it's flat. It's not a belief, really, like a religion. It's just an observation.
I'm just saying that I'm familiar with them, and I think that they're probably trying to make some sort of joke, but I can't figure out what it is.
Or maybe over the course of this discussion, he's seen the truth and he's come to the knowledge and understanding of the true nature of Earth. It's always a possibility. He could be a born-again flat earther like me.
Could be. Could be.
All right. Well, I get the screens set up. Let's move on to the next question, everybody. Thank you so much for your super chats. Let's keep them coming in. Great Sky for $20 says, a microbe sitting on a basketball from its perspective would appear as if it were sitting on a flat plane. We are like microbes on the Earth. But the Earth is bigger than a basketball by way of comparison. We live on a globe. Fact. Great Sky, thank you for your question.
Wasn't really a question, I guess, was it?
It was more of a declaration.
More
yeah, but at the same time, you know, I had to say that because it was $20. A microbe sitting on a basketball from its perspective would appear as if it's sitting on a flat plane. Let's go from there.
Generally, yeah, that's the argument against the but it looks flat sort of initial intuition.
Right, because you don't trust your senses since you've been told as a little kid not to trust your senses. You know what I mean? That's why people are in so much turmoil, bro.
Nobody ever told me that. Nobody ever told me as a little kid not to trust my senses. So
but
I don't know.
You don't trust your senses.
I do. So I don't know what you're talking about. I don't know why you would tell me that I don't trust my senses, because you don't know me, right? So.
All right.
I won't disagree with you.
All right, cool.
Let's move on to the next question there. This one coming in from JD on YouTube. Thank you so much for your super chat. If I wanted to control the masses, I would want them to buy into a fake version of the world that causes them to have full faith in what my people say. Thoughts on that? I
wouldn't. That seems extremely fragile.
Well, yeah, and that's sort of what's happening in North Korea, like what we said before, and yet North Korea hasn't made any attempt to say the Earth is flat, or so they haven't tried to fake a moon landing either. If you're saying that we faked moon landings or whatever, I know it's off topic, but
I mean, me personally, I didn't fake anything, bro. So don't say we, because I didn't do any of that.
Well, but NASA presumably did, right?
Yeah, but you said we. I'm not part of NASA, and I don't think you are either. You mean you might be?
Well,
but...
I was technically, sort of vaguely at one point.
Yeah, but I mean, you're not a 33rd though. I'm sure.
My grandfather was a 32nd.
That's believable. I don't doubt that for a second, bro.
All right. Well, we can move on from there, everybody. So we have the next one coming in from Wade Eberly for $1.99. Why is there a southern celestial pole?
That's a question for you.
For me?
Yeah, because we have a perfectly valid and coherent explanation for a southern celestial pole. But you were saying about the north.
I think it would be more like a ring, a southern celestial ring.
Do you know about the Southern Cross? So you remember how you brought up? you remember how you brought up that the North Star doesn't move, which it really does move a little bit, but you're saying everything
You
moves around
just
the
can't
North
see it
Star.
moving, right?
Yeah, this in the southern hemisphere, they cannot see the North Star. What they see instead is the Southern Cross, which everything kind of moves around too in the same way it does in the northern hemisphere for the North Star. So they have their own equivalent. How can that possibly happen on a flat Earth?
I don't know, bro.
Because on a globe Earth, we have the North Star because it's kind of spinning by the axis, and then there's a southern axis as well. So the southern hemisphere would have their own equivalent, and the northern hemisphere would have theirs, the North Star and the Southern Cross. But there's no coherent explanation for that in flat Earth.
All right, let's move on to our next. Let's move on to the next question there, fellas. Cool Biko says, for $5, the headlight of your car breaks the speed of light. Problems, chemist?
It doesn't.
All right. Any thoughts anywhere else? No. All right.
Nobody's broken the speed of light with a car headlight. I'm sorry. If you believe that, you might want to see a mental health professional.
I do psychology on the side if you're interested.
Yeah, go talk to Latter-day Saints about it if you think that. He might be able to help you out and get your head on straight, I'm sure. Wait, get your head on level.
I'm just flattening the curve every day. I'm just doing my part to flatten the curve, you know what I mean? We all can do our part.
All right, let's move on to the next one. Jake Nelson for $5. At the solar system scale, Newtonian physics have been abandoned for relativity.
That was probably more directed at what Mike was saying about that we've only done Newtonian physics to explain the movement of the solar system or whatever. So that was probably more directed towards him.
Yeah, you don't need to use relativity in order to land a probe on any planet at all. Even Mercury, which would be the one where it would come the most into conflict. But part of that is because these things are self-evaluating and self-correcting as they go. Not continuously in the case of probes, but
you also do need general relativity to explain certain aspects like Mercury's perihelion.
Yes, but that's slow enough that if you want to land a probe on it, you don't need to know about it. It'll only move it by a few kilometers, and over that distance, that means that you leave a thruster on for a quarter second longer than otherwise.
The point is that both with Newtonian mechanics and with general relativity's predictions, we've gotten accurate predictions down to very small amounts of decimal places. So,
all right, you're shaking your head over there. 20 seconds to close us out there, FDS.
I just think it's funny how people think that they can land probes on things that are millions of miles away and then actually see the video of it. It's kind of ridiculous. It's like science fiction, but, who am I to say anything?
Well, just real quick, if I could, because that was sort of a new point.
Well, we have to move on.
This latest probe, the Indian moon landing that just happened with that Indian probe on the moon, that was independently verified by independent astronomers. Go check out Scott Tilley on Twitter. He actually showed he set up an antenna to receive the signal that was being put out by that probe, and he did a Doppler analysis on it and showed that it matched that on the moon, which is extremely strong evidence that probe was on the moon. And he was independent. He's not working with NASA. He just did this with his own equipment, and so can you.
All right, next question.
He's just brainwashed, and he's just a fanboy who does it for free. You know what I mean?
Jake
they
Nelson.
got a lot of them on the Helio side, bro. I can't knock you guys. You guys got it. You guys have a lot of people influenced, bro, and believe in the trickery and the witchcraft of the heliocentric belief, bro, which is a Luciferian concept.
Let's respect Jake Nelson coming in for $5. His question: Flurfs provide a model of how sunrise and sunset works.
I don't have a model, bro. I had one, but she left me. You know what I mean? Now I don't have a flat Earth model.
All right, let's carry on from there. Great Sky, $20. Let's see. We already read that one. Sorry about that. Let's continue on. Wade Eberly asked that one as well. My goodness, my scrolling thumb's not working so well. I'm gonna have to get that thing worked out. Cool, Biko. Lordy. Yeah, we actually got through a lot more than what I thought. See, my finger, I was scrolling down through and I was like, oh, really? We answered that many questions? You guys are on fire. Honestly, you guys are rolling right through them. Keep the super chats rolling in, everybody. We appreciate Flat Earth Mike for being here on the Flat Earth side. He took off, so don't worry about him not being here. Flatter Day Saint is going to take over and answer any questions, I think, that were directed there. So, old Jay's,
like an energy weapon, you know what I mean?
Sonic Shroom says for $2, what is harmonic levitation?
Where you use sound to levitate things, which completely defies the concept of gravity.
It doesn't.
All right.
Oh, you can why don't you just draw a free body diagram and prove to yourself that it doesn't violate any aspect of gravity? Nothing is in contradiction there if you actually understand the physics. You can calculate all the forces that are acting on that levitating body, including gravity, and you still get the levitation. It's not against gravity.
All right.
It's similar to asking why don't we just like phase through the floor? It's because there are forces that prevent us from doing so.
All right, this next one coming in. This one was from Mike, from Sonic Shroom. Why can't you trust the work of past hundreds of years done by people much smarter than you? We'll hand that over to you, Flatter Day Saint, for a minute.
I mean, I don't trust anything, bro, that I can't test for myself. I don't trust anything because I was lied to as a kid by Santa Claus, by people who really thought they were doing something good, you know, but they weren't. They were telling me it's bad to tell lies while they were telling me a lie. It's all part of the psychological terror that they impose on kids, you know, the brainwashing, bro. It's state of the art and there's nothing like it.
All right, let's carry on to the next question there. LJ says, even my dog knows all the moon landings were faked. Well, thanks for that, LJ. That's more of a declaration. Jake Nelson for $5 says, Darwin was wrong. Tesla was wrong. Jake Nelson also said, at the solar system scale, Newtonian physics has been abandoned for relativity.
Jake Nelson says a lot of things because he's having fun. I love you, Jake.
Any other thoughts?
What was the last thing he said?
So the most recent thing that he put in there was Darwin was wrong and Tesla was wrong.
But he said something else after that.
He was putting in context of the earlier things.
Yes, at the solar system scale, Newtonian physics has been abandoned for relativity.
I don't know what he's saying about Darwin. Yeah, I don't know.
All people are wrong about some things sometimes.
Except for me, because, you know, I'm perfect.
Except for Tapiocaweasel.
Don't forget
Hey,
about
did you get your name from Corny Beaver? Is there any similarities right there? Because you're naming a food product and then an animal afterward. I'm just wondering.
No. Good question, though. I don't really, there's not really a good explanation other than it was a random collection of words that I remember thinking of when I was like coming up with a username literally back in high school. And I'm 31 now, so that was a while ago. It doesn't come from anywhere.
Next one.
I thought you were going to say you're 33. You know what I mean?
Next one coming in from our very own moderator, Yadian. Radiant Yadian. All right, no more singing. If you put a helium balloon in a shipping container, close it up, then drop the container out the back of the plane, the balloon won't rise to the top of the container while it falls. If everything is density, can you explain?
That'd be for Latter-day Saints.
Can we?
I'm sorry. I was just starting the vehicle because I'm gonna pull out of here. So if you could just repeat the question.
That's no problem. So Yeah, if you put a helium balloon in a shipping container, close it up, then drop the container out of the back of the plane, the balloon won't rise to the top of the container while it falls. If everything is density, can you explain?
I can't explain it, bro.
I actually don't know
I
if
don't
that's
understand.
true.
I don't understand how it works. I just know that there's too many things that defy gravity and they contradict gravity. Magnets, helium balloons, smoke, airplanes, fish not going to the bottom of the ocean but swimming freely. These are just some examples of anti-gravity or whatever you would call it. It
Not
debunks
only,
gravity.
not only are none of those contrary to gravity being real, like there are completely coherent physical explanations for every single thing that you just listed within the framework of gravity. So I'm sorry, man, but
Any other thoughts there, FDS, before we move on? Or you got some thoughts there?
I'm not going to stay on a stream with somebody who's driving. It's like a policy that I have.
Sorry, I'm about to park, but if you want to hang up, you can. I just couldn't stay where I was at.
Oh, okay. If you were just going to like keep going.
No, I'm just looking for somewhere to park.
I can wait.
All right. Well, we have this next one coming in from Wade Eberly for $4.99. If the sun disappears from view because it's getting too far away, why does it have the same apparent size all day, even when it's setting?
This is what I brought up in my intro as well, that the angular diameter of the sun does not change substantially at all. So, yeah, he's basically bringing up a similar point that we talked about.
I would disagree with that. I'd say when the sun is rising or setting, it's a lot bigger and it's a lot less bright than it is when it's high noon overhead, when it's really bright and really small, just like a flashlight would be.
So do you have measurements of that?
It's just observable, bro.
I do not observe that. So I would like you to measure that. If you claim that it's just observable and we can all see it, then just, try to find some measurements or measure it yourself.
I'm just saying it's clearly observable, and I find these truths to be self-evident.
All right, next one is
if you don't observe the same
how
thing
many
that I
how many
observe,
more do we have, by the way?
We only got 3 more.
All right.
And then we'll go to our closing statement for each and every one of you. So Sonic Shroom, no, that is acoustic levitation.
Oh, acoustic as opposed to harmonic levitation?
I think so. Maybe.
Yeah, couldn't tell you.
Harmonic is a term that is applied in a lot of places where it can sometimes be a surprise.
Yeah, let's just go to the next question.
All right. Sonic Shroom says for $5, do you test how the cameras that you are using gets your image to me? I think that's for you there, FDS.
Do I test how the cameras I'm using get to him? What is he saying, that he has my camera now?
I'm not sure. I will.
Maybe he's talking about how when you said that you don't believe in anything that you can't test. Maybe he might be talking about, have you tested? I don't know. I'm just trying to figure out what he's asking.
All right. So
I mean, I'm very well knowledgeable about cameras. I've had a Nikon D850, a D800, a P1000, a P900. I've owned over $15,000 in lenses. One summer, I took 350,000 photographs with the P1000. I'm not a professional, but I've had my share of moments with cameras. You know what I mean?
All right. Well, let's move on to the next super chat. We're almost to the end, everybody. And thank you so much for all your super chats. Greater Sky for $5 says, Latter-day Saint, if we were on a flat earth, wouldn't sunsets and sunrises be more like a light turning on and off rather than a slow, gradual change?
If we were on a what? Sorry?
If we were on a flat earth.
Oh, okay.
If we were on a flat earth, what?
If we were on a flat earth, wouldn't sunsets and sunrises be more like a light turning on and off rather than a slow, gradual change?
I think it would be the same whether you were on a flat earth, a triangle earth, a spherical earth, a disc-shaped earth.
Right.
Neil deGrasse Tyson even says so.
The geometry would be fairly different in all of those cases, but in none of them would you be able to replicate a sunset. So
Last one coming in from Cool Beco for $5. Wasn't FDS drinking before? Imagine sitting on a merry-go-round that rotated at 15 degrees per hour. Would you even feel it?
He's saying I'm drinking. Yeah, I'm drinking water. It's just water in a glass bottle because I don't drink out of plastic.
There you go, Cool Beco. Imagine sitting on a merry-go-round that rotated at 15 degrees per hour. Would you even feel it? Last super chat. Any thoughts there, or shall we move to our closing statements? All right. I think that sums it up, everybody. There were no thoughts on that last question. Ryan was met with just the crickets. Oh, my heart sunk. I was like, did I mess up? Did my sound screw up? You know, what's going on, fellas? Let's move into those closing statements. 1 minute. Let's start with you there, base theory. 1 minute for your closing statement. Floor is yours.
all right, so yeah, we didn't hear any explanation about how a sunset occurs. I mean, I applaud both my opponents for saying that they don't know, they don't have the model. That's fine. I appreciate them for being truthful, but yeah, the globe model easily explains sunrises and sunsets, easily explains antipodal focusing, easily explains all the points that I had at the very beginning of that slide. I could have easily picked any single one of them. All of those debunk the flat Earth. And I didn't really hear anything cogent from either of my opponents tonight that debunked or was even a challenge to any of our current understanding of physics or the globe Earth model. So
what about when I talked about water always seeking its true level? You didn't have any explanation except something you invoked called gravity.
Yeah, gravity is not just something I invoked out of nowhere. Gravity is observed, and you can go and look at the definition of level used in land surveying, and it is level with the curve of the Earth. That's the definition.
I love the liveliness, but
and black means white, right?
This is supposed to be 1 minute for the closing statement. Nominal for our member says heliocentric universe is 95% imaginary. Nominal, if you have time, join us for the after show. Maybe we'll get some afterthoughts. We're gonna
I can't respond to that. He's just talking about dark energy and dark matter, which are not imaginary, so he's wrong.
All right,
dark lives matter, right, bro? Dark hole lives matter.
All right, let's not talk about dark holes, everybody. We're going to get demonetized. My goodness. How sexy do we need this stream to be? All right, let's hand it over to Dr. Tapiocaweasel before we hand it to Flatter-Day Saint to close us out. Doctor, the floor is all yours.
I would just like to reiterate a point that I brought up earlier. If you drop an object from here and then you drop it from higher up in the same room, and you control for all the variables, you control for electric and magnetic fields in all sorts of we have, I mean, we have ways of measuring and controlling for these things. The object will fall faster when it's closer to the ground because it's closer to the source of gravity. I don't see how that happens in a flat Earth.
Shouldn't the object always fall a little bit away from where you dropped it because of the spin of the Earth, though?
No.
Exactly. Actually, they do that. They do that by an amount that is dependent on the angular velocity, which is really, really slow.
All right.
It's unmeasurable, right? We can't see it, taste it, touch it, feel it.
We can absolutely measure this. This is absolutely something that we can
30
measure.
seconds to Dr. Tapiocaweasel there before we
hand it over. If you when you do artillery launching, you have to take these things into account. For example,
not true.
30 seconds. Like
you're
I said,
just wrong.
I'll give another 30 seconds to you, Doctor.
No, I'm done.
Are you sure? Okay.
Yeah.
Well, 1 minute there, Flatter-Day Saints. Your closing thoughts.
Well, just like all the other people I've debated and the people I bump into daily when I flat smack, I don't really believe that you guys are genuinely being knowingly dishonest. I really truly believe that you guys really believe what you're saying is true. So I just hope one day you come to the truth and trust your senses and not trust what anybody else tells you unless you can prove it, and just test all things and hold fast to that which is good.
All right. Well, we appreciate everybody for being here. Mike, Tapiocaweasel, a Based Theory, Flatter Day Saint. You guys have been a great panel to have tonight and having this discussion. We want to remind you that DebateCon 4 is coming up. You can get your tickets in the description in our YouTube link right now, along with all of our guests, which will be tagged post this debate. So if you like what you're hearing, you'll be able to find them at their links in the debate, whether that's a Discord link or their YouTube link. We'll try to get you connected to these speakers here. Last thing I will mention here is that Dr. Dino says after show up open mic for whoever wants to join. So Dr. Dino is having a show over at his channel. So head on over there if you want to getting some after show. I'm not sure if I'll be there. I'm gonna go make some grilled cheese, because that's what we Canadians do. We just indulge in all that great nonsense. So I hope
some flapjacks, bro.
that's right. I need that flat cheese in my body. All right, so everybody, I hope you enjoyed this. I hope you had a ball, just to make an opposite pun. Anyways, have a good time, everybody. Cheers.
They need all the help they can get, bro. I ain't mad at you. They need all the help they can get. You know what I mean?
All right. Well, without response, we're going to try to close it out. Thanks, everybody, for being here. Hopefully, we'll see you for DebateCon 4. If you can't make it, you can, like I say, donate to the Indiegogo link at the bottom there. We super appreciate it, and all your contributions to helping these live events happen and what we heard here tonight. We'll see you for more juicy debates. Enjoy some of my screaming in your ear and some guitar solos. That's what I like to do. Good night, everyone.